Skies were blue, yeah, but that was yesterday. Every day was a nice day in the Bay Area. Then the smoke came and knocked upon our door. Skies were blue, but they sure ain't blue no more. Orange skies over the bay, nothing but orange skies every day. Bluebirds coughing up phlegm, I do the same thing, just like them. We always had fog, lots of it, man, but now it looks like a lousy spray tan. Nothing in English rhymes with orange. That's why this line here, well, it don't rhyme. But blue skies seem to be gone. Now we got orange skies from now on.
It's a god-awful hot affair on the planet with 900-degree air. To see her surface, probes must go low. Then it's too hot, so they call out no. She's the second brightest object we've seen. Now we've detected in her clouds phosphine. The scientists have the clearest view, but they're still not sure what it means. 38 spacecraft have been before, but but so hostile she's hard to explore. Mars hugs NASA's attention and tools, but now we ask them to focus on Venus, fighting for the limelight. Oh man, could microorgs be next door? Something we shouldn't ignore. Her terrestrial surface giving us a big clue. Oh man, wonder if we'll ever know if she's got life in her glow. Is there life on Venus?
Okay, I think we are starting. So welcome to All Space Considered, produced by Griffith Observatory, no longer at Griffith Observatory for obvious reasons. So here we are bringing you on the first Friday of the month, as we have been for over 10 years. Some news and discoveries and exciting things happening in the world of astronomy and space. As usual, the three of us are here. I'm Dr. Laura Danley. I'm the curator of Griffith Observatory and your host for this evening. And with me is Tony Cook, our astronomical observer, and Patrick So, our theater and planetarium manager. And usually we have Dr. David Reitzel with us, but as of about 10:30 last night, he had to cancel his participation tonight. He has a family, well, I'm just going to go ahead and say some illness in his family that we're all keeping our fingers crossed, and our hopes and prayers for him and his family that all is well. So he'll be back with you next month, and we will miss him tonight. So we've had to make a few adjustments to our program tonight, but we will prevail. So I do want to say a couple of quick thank yous. I'd like to thank the City of Los Angeles and the Los Angeles taxpayers for keeping us afloat, because Griffith Observatory is owned and operated by the City of Los Angeles, and your tax dollars, if you're an Angelino, is what keeps Griffith Observatory going. But they don't do it alone. They do it with the help of a Friends organization, Friends of the Observatory. And you too can be a member and join Friends of the Observatory. So they help us with a lot of programming support, and we are grateful to them as well. So for all of you who might be watching, we thank you for your support. And we're so glad we're able to continue to try to bring this program to you, even in the most trying times. And with that in mind, I do want to say these are most certainly trying times. So a special thank you for all of you who came tonight and are watching tonight, given the headlines so fast and furious, the news so grim and uncertain, and frankly, downright scary. So we hope that we're able to, bring a little light and a little levity into your Friday evening. With that said, we do want to extend our greatest wishes for a speedy recovery to the President and the First Lady, and to all of those who are supporting them and surrounding them, and the healthcare workers that are helping them, and all of those who are sick with this dreaded disease. It's a serious, real challenge to our country, to the world. And, every month we try to help understand and help reveal more about the way in which science works and why we rely on science to give us understanding of the world around us, but also to teach us how to survive and be safe in the world around us. So it should not come as a surprise to anyone watching that we urge all of you, and I'm sure if you're watching this, you probably already feel this way, but in turn, please urge those around you to keep an eye on understanding and the science behind such things as pandemics and other, important issues facing our society today. This is not the way we usually start All Space Considered, but in light of the challenges that our country and the world are facing right now, I wanted to make that, that comment. So with that, Bill, if you are handy, we didn't discuss this. Are you going to tell us about that music we just listened to?
Absolutely, of course I am, as I always do. Good evening, ladies and gentlemen, girls and boys, and all you science lovers all around the world. We're all watching us right now. Here at All Space Considered, we love science, music, and fun. So tonight, as always, we'll be playing our music game during the course of this presentation. A lot of you are regulars. You already know the rules, but here they are again. We played music on the stream prior to the show tonight. We used to call this our walk-in music when we had a theater. Now we call it our log-in music. Each piece of music is somehow connected to at least one story we're presenting. If you guess that connection, you win a prize. To make a guess, include the name of the song or some identifier of the piece that you heard and the story that it's connected to. Then enter your answer either in the chat section of YouTube or tweet it at us at All Space Considered. All Space Considered with all the vowels ripped out of considered. Up to 2 prizes will be awarded for each song. One for the first correct chat and one for the first correct tweet. You will be able to pick up your prize at the next All Space Considered that we actually do once we're back in the observatory again. So just step right up to the desk and demand your prize. And we have some great prizes as always. We have mission stickers, we have pens, we have posters and pins and other assorted fun prizes, calendars, posters. Did I say posters? Yeah.
How about pins and calendars?
Pins and calendars. Well, calendars, of course. Now, this is the part that everybody laughs at always. Is this visible? I just want to check. Yes. Okay, good. But I'm totally serious. You can reuse calendars. We have a bunch of beautiful calendars that we still have in stock from previous years, and they are beautiful. And this one in particular, I always like to show off the incredible photography of our good friend and brilliant museum guy, David Pinsky. This is, of course, a night shot of the observatory. This is a 2019 calendar. Now, a 2019 calendar will be useful again in the year 2030, just about a decade away. Just stick it in your put it in your IRA. No, you can't put it in your sock drawer until that day. A 2018 calendar is good again in 2029. A 2017 calendar is good again in 2023. And that just goes right along with our motto of reduce, reuse, and recycle. And please enjoy the show. And let's see you, Doc.
Thanks, Bill. I had to ask him, hey, we didn't talk about this because like a lot of people, many, many hours have disappeared out of our days yesterday and today. And of course, the 36 hours prior to a show evening is some of the most intense prep. So we will do the best we can. We know you'll have some understanding for the things that have to change or not quite right, especially with David's absence. So we apologize for that in advance. But we're going to do our best to tell you the latest and greatest and hope that you enjoy tonight's program. So as you can see there, we've got All Space Considered, the first Friday of every month. And Bill mentioned the many ways in which you can get in touch with us and stay in touch with us. So I hope we're showing the screen. And moving forward, today is October 2nd. And so our stories for tonight, how many of you, oh gosh, we're not there, so I can't see how many hands go up. How many of you watched, saw the headline that life is discovered on Venus? Got quite a lot of play, and we're going to tell you what that's all about. And Patrick's going to tell us more about our latest swing past Jupiter and what we've learned about that world. And then there's another fantastic, couple of missions in the asteroid belt. And Tony's going to tell us a little more about that. He's also going to tell us a little bit about spaceflight update. And Tony, I'm going to just say that I got a text from a friend of mine. I used to live in Baltimore when I worked for NASA. And so I have friends in Maryland who said, we just saw the launch. So even from our time, we were together an hour and a half ago, just running through all the slides, things have changed, but that's how it is in space science. It's a helicopter. And so he'll be telling us more about that. And then, of course, as always, the Sky Report with a little bit of a focus, no pun, well, okay, maybe a pun. on astrophotography, because this is a month, if you haven't done it, and if you have, there's some great things. In particular, one great thing that Tony's going to tell you about that you might want to pull out your camera and telescope and give it a try. Then we have an extended pretty pictures. It turned out we had so many pretty pictures, it ended up being kind of long, but that's fine. Long pictures, short break. We have a couple videos, as we always do. And then in the second part of the show, especially if you live in Los Angeles, you know that this has been a dramatic couple of weeks. We last show talked about the fires threatening Lick Observatory. Thought we might be done with that topic, but no, because 2 days later is in our own backyard. And so we have more to share there, with a special visit with Sam Hale, who is the grandson of George Ellery Hale, the founder of Mount Wilson. That's a video interview. He was unable to be with us this evening, but we wanted to get his personal perspectives on things. So we'll be enjoying that together. And then we thought we'd try to take a look at what the issues are. Some of you, especially if you live in California, know that there was a recent conversation between our governor and our president about what is the cause for these fires, what needs to be done to mitigate these fires. And so we're going to talk a little bit about forest management and also climate change, the two primary factors that people are talking about as the possible and probable sources for the kinds of issues that we've been facing. So that's our program for tonight. So, oh yes. So I have discussion question mark because, well, let me just say, people have opinions about this and they have questions and they sometimes disagree or may doubt some of the things that I might say. So we're really going to try to incorporate discussion. Even though you're not all here in the Zoom room, we do have a representative. And Brendan, if you want to come in the room. There's Brendan. Hey, Brendan. Brendan and several other staff members are monitoring the chat, and they're on the YouTube channel. And is someone monitoring the live stream channel?
You're also monitoring the live stream. So we've got you on both sides.
So if you have questions or comments or anything, and you wanted to come into the room, Brendan will be happy to join us and speak for you and share your question. And we will try to enable that a little more than we have in past times. So don't be shy, ask your questions, and Brendan will bring them to us. Thanks, Brendan.
We will also be passing them along just via text if we're in the middle of speaking or something. We're getting the questions there, even if I don't pop in and interrupt mid-sentence for someone else. Anyway.
Yeah, or through the chat. Perfect.
Yeah.
Perfect.
All right.
Okay, great. Thank you. So on to our first story. So some of you have seen a site like this, maybe not this particular location. And if you're like me with a small computer screen as opposed to a huge HD projected image, as we often have, you're trying to see what in the world is the important thing in that picture. Well, the important thing in the picture is that little white dot there, and that is Venus. Venus is the nearest planet to Earth. It's the third brightest thing in the sky after the sun and moon. So it's really hard to miss. And if you've been up in the mornings before dawn, you see it. You can't miss it. It's bright. It's beautiful. It catches your eye. Some of you might remember last April during the shout out for the healthcare workers. It was brilliantly bright in the evening sky, but because the planets move in their orbits, Venus is now visible in the morning sky. So you have to get up early to see it. It'll be that way through the rest of the year. But it's a stunning sight. And for most of human history, we didn't know what it was. It was a light in the sky. So what does that mean? Well, it's been associated since about the 13th century with the goddess Venus. And Venus, as you know, goddess of love, and probably because it's so bright and eye-catching, and so celebrated in song and art. And if you want the more PG version, oh yes, the Venus de Milo, little uncertainty as to who. I always learned when I was in school that it was Praxiteles who carved it, but I understand that's a little under debate now. So I'm not an art historian, can't tell you that. But we do have a PG version in case the kids are watching. there she is, a little less of a seductress, but still having a fun time dancing in the forest. So that's our sort of societal thoughts about Venus. But of course, Venus is a world in the sky that goes around the sun. And this is kind of a cool slide because if you haven't looked at it through a telescope, you may not know that Venus has phases just like the moon does. And you can tell from the way this drawing is that when Venus is on the far side from the sun, you see more of it being illuminated, but it's farther away. But as it comes around the bend and comes closer to us, we see less and less. We see it in a crescent form, but it's a larger planet. So that explains how we see it in the sky. Oh my goodness, question already. That was fast. Do any of the moonlets themselves, does Jupiter have? You know, I'm going to stick to Venus for right now. I appreciate that question, but we'll take, at the end, we'll take questions not related to the story at the time. It's a question about Jupiter's moons. So anyway, otherwise we could get derailed and, well, you know, that wouldn't be a bad program. In fact, I gotta say, this is a discussion that we're having is about the next program, especially with the election coming and a lot of other uncertainties, that we might have a Q&A only show the next time. It's something we're contemplating. So I'll come back to that a little bit later. But let me return to Venus and try to get to the headlines here. Venus, of course, is a planet. As I mentioned, it's sometimes referred to as Earth's twin because it's about the same size, but it's closer to the sun and hotter. As a result, the water has boiled away. It has turned into a runaway greenhouse, and the surface of Venus is 900 degrees Fahrenheit. The atmosphere is thick and acidic. It's 90 times Earth's atmosphere, not a hospitable place. So one of the questions we like to ask is, you know, what happened? Why did our twin become so different from us? Here's a kind of a cool picture in the ultraviolet. And you see different things when you look at different colors. So I'll come back to that actually in a little bit. So why are we talking about Venus tonight other than it's bright and beautiful? It's because of this paper, Phosphine Gas in the Cloud Decks of Venus. And this got huge attention and was translated by the media as life on Venus, or maybe we should say life in Venus, because it's not on the surface, it's in the clouds of Venus. So that's another one for the 2020 bingo. And I actually really like this one that, you know, water on Mars, everyone's been talking about Mars. Don't really care for the violence of the bus being hit by the train, but nonetheless, Venus has come barreling through as a real contender for life. So why is that? What makes us think that that is the case? Well, this paper that was published earlier this month, interestingly, was a follow-up with some of the same people who studied phosphine because they were looking for phosphine and want to look for phosphine as a chemical signature of life in extrasolar planets. We can't really see extrasolar planets very well, but we can make measurements of the chemical compositions in their atmospheres. So astrobiologists, people who are trying to learn about life beyond Earth, want to find what are the chemical signatures, the chemical fingerprint that can tell me that there might be life. So one of the signatures that was identified by this group earlier in the year, this is January 2020, recognized that phosphine, and that's phosphorus with hydrogens all around, not to be confused with phosphate, which is hydrogens with oxygens all around in an OH group, might be a signature. On Earth, phosphine is formed by life. So as I understand it, I heard a talk last Sunday from Robert Grimm, who's at Southwest Research Institute. And he had the inside skinny, I don't know this personally, but he said that they looked at Venus as a control to tell us, okay, we know there's no life on Venus, so let's measure what the phosphine levels are, expecting a part per billion or something, and then we know what an upper limit is when there's no life. We have a measure of what no life looks like. And lo and behold, that's not what they saw. They saw phosphine molecules in the atmosphere of Venus. This came as a shock to them. So actually the group publishing this is not so much a a planetary science, you know, the Venus crowd that goes and studies Venus. It's more the astrobiology crowd who were using this for a control. This is what I've heard. So I hope that's true because it's a great story. So how did they do it? Well, they looked for the chemical signature spectroscopically in long wavelength, millimeter radio wavelengths at these two telescopes, at the James Clerk Maxwell telescope on Mauna Kea and at the Atacama Large ALMA, Atacama Large Millimeter Array, I think it is, in Atacama Desert, Chile. And so these show you what they saw. Those wiggles are spectra. And as you can tell by the line they drew in, there's a dip there right in the middle. Now, it doesn't look very convincing, but they claim that it has enough what we call signal to noise, that it's not just noise, but that it's really there. And that's the Clerk Maxwell telescope. When you look in ALMA, it's even clearer, a very clear detection of this chemical. Now, this is really fascinating because, as I mentioned before, the phosphine molecule they tried everywhere. And they did this for the earlier paper, the January. How can you create phosphine? Can phosphine be created, and the word is abiotically, without biology? And the answer is they couldn't. They tried everything. They tried, chemical reactions of different types of atmospheres, and with lightning, and with meteor strikes, and all kinds of different ways to maybe create this molecule. And I should say, of course, the study was looking in terrestrial conditions. So the types of temperatures and pressures that you see in the terrestrial, what we call the habitable zone, planets like Earth. So very clearly, can't do it any other way. As I mentioned, on Earth, it happens from microbes, anaerobic microbes that don't live in oxygen, and also through industry. It is a byproduct of industrial processes, but those, of course, are biotic as well. So until we get to the machine age where machines are making machines. But for now, machines are being made by people. And so again, phosphine on Earth is always biotic. Now, it has been seen in Jupiter. And honestly, this was David's part, and I think we forgot to take it out. So he read a couple of papers. I do know that and I'm not familiar with this, so I'll just do my best to represent him, but that it's deep in the atmosphere, or although it's convected up through the atmosphere, that it happens deep at very, very high pressures and in conditions on Jupiter, which are nothing like terrestrial conditions. I don't know if either of you want to add anything about it, because if you know anything, please do. Any takers?
Just that life is not expected to be involved with that.
That's right.
Yes.
So there is an abiotic pathway, but in conditions that are nothing like a terrestrial planet. Anyway, those are those papers that David was going to talk about. We mentioned that the surface is quite hostile. And so we now know that this, here's a nice little picture from Magellan of the surface, if you could strip away the thick cloud top. And in fact, we've landed a couple of missions on the surface. We humans, the Soviets did. And there's a lot of interesting history there, which if we have all kinds of time later, we might talk about. But for now, we know that the surface is completely inhospitable to life. Question, why isn't Venus a gas giant? Why aren't there any gas giants in our inner solar system? That is, and that comes from Roger, and the second one from William. Fantastic question. Largely because, I'll take the first one, which is why isn't Venus a gas giant? Largely because it happened so close when the solar system was forming, close to the sun, that first of all, there wasn't as much material. Think about the circumference of Venus's orbit compared to the circumference of Jupiter's orbit, sweeping up all that material that comes together. And secondly, because as the sun was born and got hotter and hotter through the stellar formation process, it heated up and essentially blew away and boiled away all the gas that was in the inner solar system. So we didn't have all that gas to accrete and build up to be a gas giant, like the outer solar system, which was cooler and had all that gas and that long pathway to sweep up all that material. So inner solar system has all these little rocky guys like us and Venus and Mars and Mercury. Outer solar system has the big gas giants. Let me see if I want to. Yeah, I'm going to go ahead and take William's question right now because I love this question. If life is ever found, how will we know for sure? This is one of my favorite questions because you really hit it, William, on the idea that, okay, they didn't find bugs, they didn't find cities, they didn't find anything wiggling around. They found a molecule that through our work as chemists on Earth, we have found we could not recreate any kind of chemical pathway to make except for life in those conditions, in terrestrial planet conditions. And so I love that question because I used to, when I was a professor, ask this of my students: when would you personally be convinced? Do you need to have a conversation? When does that finally cross the threshold? And it's different from different people. Some people could care less about a bug. I personally think a bug is fabulous. I would be thrilled to have a microbe. I'd like to know if it has DNA like ours, see if we have a common chemical origin, but is just a molecule enough? It's really not. In other words, and that's why the title of the paper is not Life on Venus. The title of the paper is Phosphine Found in Venus Atmosphere. It focuses on the molecule. So the press that went like Life on Venus. But scientists are conservative. We're not going to go into wild leaps. Actually, with that said, I'm about to say a wild leap because in our story here, we were talking about the fact that surface is incompatible. So it's thought to be life in the clouds floating around on Earth. We don't have life in our clouds. Bugs get up there, viruses float around the atmosphere, but their origin is on surface-based life. And it circulates, but eventually will come back to the surface. There are no independent ecosystems where life is, born, lives, dies, and evolves, never touching the surface of Earth. So if that's the case, well, we have a lot to learn. So far we have phosphine. I mean, really, really begs the question, what is this? What's creating this phosphine? And what is the prediction then of what kind of life? And once you sort of infer or postulate, hypothesize what life would be like to create this, hypothesis will give you indications of your next observables. So you have to go back and study it further. First of all, this vaccine detection has to be confirmed. This is the paper. I think they sat on it for 2 years or something before publishing because they're like, I don't know this. So it has to be confirmed by other science. That's also a scientific method. You can't just make stuff up. It has to be reproducible. Other people either reproduce it or don't reproduce it, and then there becomes a kind of a battle of people trying to ferret out what is actually true. So that is the next step, is to reconfirm these observations and then make predictions about what other things we ought to be able to see if this is created by life, and go look for those things. So that is a perfect example. Oh, moving on. So yeah, there are no cloud cities. There are probably bugs if they're there at all, but the main thing is they're aliens. That's a slide if you've come to All Space Considered before that we have used more than once. Okay, so I mentioned about not wild speculation, but here's this image that is from Akatsuki. I'm terrible at this, and I can't even read it. Akatsuki. There we go. I said it. Japanese mission that measures all this ultraviolet. And I also heard in this talk on Sunday, there's an ultraviolet spectroscopist who says, and it is, well, this is true, that bugs, anaerobic bacteria, can absorb in the ultraviolet. And so he has speculated, and I noticed the use of the word between speculated, hypothesized, theorized. They all have, they're nuanced and have different meanings. He has speculated that maybe when we're looking at those dark clouds, those are just clouds of microbial colonies all floating around the atmosphere of Venus. So I wanted to share that, even though it's a speculation, just because it's kind of fun and because that's a super cool image of Venus. Okay, so just to finish up, Venus, as we said earlier, used to start out like Earth, but it underwent a lot of changes. There was a lot of volcanism. Again, as it cooled, because it was molten. In fact, there's speculation that there's volcanism today. And as the carbon dioxide levels grew in the atmosphere and the other greenhouse gases, it just got hotter and hotter and hotter. All the water boiled away. Things, it was a runaway. It's a runaway greenhouse. And in fact, it was studying Venus that led Carl Sagan to try to draw the analogy to Earth and understand whether the same challenge would face us. So then, as I mentioned earlier, we want to go back. And so, I guess that's the next one. There are a number of missions that are slated. And NASA reacted very, very enthusiastically to this news. There's been all these missions to Mars, and Venus has been, the poor cousin who just hasn't gotten the attention that Mars has. And but there are some missions coming up, most notably Veritas is one of them, and Da Vinci coming up very soon. These are proposed, not, we still have a ways to go, and NASA needs to build a strategy about it. But there is no lack of competition for dollars to send us back to Venus to take those next steps and study the next bit. So has maximum temperature been established for the possibility of life? Great question. I'm not going to give you a number because I don't know that number, but we know it's more than 212 degrees Fahrenheit because we know that microbes, even though you're supposed to boil things to sterilize them, microbes can survive. They survive in the boiling mud pots of Yellowstone. So we know it's higher than that. It's not just what temperature water boils at, but at some point, molecules are pretty fragile things. You've got these atoms, think of those Tinker Toy kinds of things. You've got these atoms held together by bonds. And once it starts getting hot and they start getting jostled around through all the heat, they're gonna fall apart, and you need molecules. And in particular, life, as we know it, carbon-based life, needs these long chain molecules, and they're very fragile. So 900 is, I'm gonna go out on a limb and say 900 is too high. I don't think any molecules can live at 900 degrees, but it's a significantly lower than that, but above 212, which is kind of interesting.
Can I say one thing about that too? Yeah, well, one interesting thing about where it's found at the top of the cloud layer, I guess that's what we're looking at, is that that's actually probably the most terrestrial type conditions anywhere in the solar system, in that if you were, say, in some kind of balloon floating there, your weight would be very similar to here on Earth. And the pressure, well, it's 100 times Earth's atmospheric pressure on the surface, it's actually the same pressure at that layer, at that level, roughly 100 kilometers or so above the surface. And so the temperature and pressure are not extreme compared to Earth. It's just a carbon dioxide atmosphere, but the acid clouds and stuff are a bit lower.
Thank you. Absolutely true. And water can be liquid. Oh, somebody's got an echo happening. Water can be liquid on the in those conditions as well. So if water is essential for life, which we think it is, then you would also have liquid water. All right, I'm gonna just finish by saying, I don't know why we need to send all these missions, because we found life on Venus, and if you want to see the footage, here it is. Okay, well, we never tire of William Shatner here at All Space Considered. So anyway, I actually do have one more coded, and that is that, you know, we talked a little bit earlier about Venus in the arts. Venus is also celebrated in opera, and I'm going to do a little self-promotion here. I'm so excited about this, a program with James Conlon, the conductor of the LA Opera, October 22nd. The tickets, which are free, but you must have a ticket so you can get in the Zoom room. They're going to put a limit on it. And it will be in the Zoom room as opposed to sent on, you know, YouTube. They were going to do Tannhäuser this October. And we were going to have Conlon in May. You might remember we were going to do a thing about Pélias and Malzahn, because from time to time I indulge my great love of music and make some kind of lousy excuse for why this is about space. And Tony and I share that. We talk a lot about classical music together. So I'm just very excited because Tannhäuser spends the first two scenes of Act One in Venusberg, having a debauched time with Venus. Very racy, and so hey, Venusberg, that's got astronomical implications. So we're going to do this program together, October 22nd. If you like opera, or even if you don't, but I think it's going to be better if you do, because Wagner is a heavy place to start with a little opera. Then please do join us, because I think it's going to be really fun, and I'm totally excited about it. And then finally, in the world of shameless self-promotion, I have created my own Twitter account. I have never done any social media, period. But a couple of days ago, maybe a week ago, I created my own Twitter account. And as you can see, I have 0 tweets. I haven't anything. I don't know quite what I'm doing with it yet. But 11 nice, totally nice people followed me. So it would be so lovely. And thank you, Tony is one of the people following me. To ask, I promise I'll start tweeting something as soon as All Space Considered is over. And so if you are up for it and are on Twitter, it would be really nice. Then I wouldn't feel like nobody's out there hearing me. Okay, so now finally moving to that gas giant planet with a big, thick atmosphere. Patrick, you want to tell us about
Yes, Juno. This is NASA's mission to study the planet Jupiter with the Juno spacecraft. And last month, it made its 29th close pass of Jupiter. And the point of close passage, which is right over the North Pole and just close to the clouds of Jupiter, if we go to the next slide, is indicated as Perigove 29, which it hovers over, which the spacecraft hovers just about 2,600 miles above the cloud tops of Jupiter, which is so close.
I'm going to interrupt you. I'm
Yes.
sorry, but it's 8:08 to my shock. I guess the questions add to it, which is great. But something special happens at 8:10. Can we say just a word about that? Because I wanted to take a break right at 8:10.
Okay. Yes.
I
do you want to do
that? Yeah. How many of you have seen the full moon? I mean, like last night. The moon is coming exceptionally close to Mars in 2 minutes, is its closest approach from Los Angeles. It makes a difference. We learned this from Tony last week, that it really makes a difference which city you're in, because the parallax, the shift of the relative to, makes a difference. But so we actually wanted to take a 1-minute break and have each and every one of you go to a window or go out your side or your front door, look east. You can't miss it. Look for the full moon. I'm going to go back there to it because I want to see this right at the time, which is 1 minute away of this close approach, if you want to see a really stunning and wonderful picture. And Patrick will talk about it in the Sky Report. Not picture, reality of the moon passing less than a degree from Mars. I hope you don't mind, Patrick. I'm so sorry.
Oh, no, of course.
But let's take a 1 minute break, and I'm gonna do it. Gotta find some. Oh no, you're gonna see I'm wearing shorts. Okay, well, so at least I have pants. Everybody, go outside. We'll be back in a minute. Beautiful moonrise. Absolutely gorgeous. We'll wait for Patrick, but yeah, that looked like more than a degree though, Pat. I thought it was supposed to be less than a degree. Or is my judgment poor, Tony?
Well, Chris, I wasn't able to see it because my neighbors' houses and stuff across the street and trees, all kinds of stuff. So I wasn't able to spot the moon. But remember that the moon is half a degree, so a degree, two moon diameters. So it may look bigger than it is.
Yeah. Okay.
It may
well,
look.
If you're here in California, and in fact, go ahead and put something in the chat if you saw it and tell us what you saw. Absolutely beautiful moonrise here in Los Angeles. Barely see it also because it's still pretty low and there were houses, but really a beautiful sight. So I'm glad I interrupted myself and interrupted you, Patrick. I'm sorry. But you know, one of our goals at Griffith Observatory is to get people to look up at the night sky and take a moment and see their place in the cosmic perspective. So, so I hope you had a chance to do that. So, Patrick,
yes. Yeah, that was wonderful. I just saw it above the treetops. Okay, so the closest point from the Juno spacecraft to Jupiter is called Perijove 29, and it's indicated there. And basically, it takes about 2 hours for it to go from pole to pole around Jupiter. And at this time, JunoCam actually took lots of pictures, as it's been doing so every Perijove passage. So we're going to show you just a few of the pictures that I took on this go around. And so let's go with this slide here. This is a beautiful image looking kind of at the bottom there is the North Pole, and then just the camera's kind of pointed about 77 degrees north. And we're just about 2,100 miles above the polar region of Jupiter, where you can see those beautiful cyclonic swirls and this kind of bluish tinge that the polar regions of Jupiter has. In the next slide, we look at that white feature as it's Jupiter has Juno swings around Jupiter. We can see a folded filamentary region, which is that kind of white, kind of folded squiggly feature there. Next image. This is what you would normally see with your eyes. This is called a true color image. So all these images that we see are really color enhanced. And in the next image, we can see a color enhanced image of the same picture showing the clouds. And you can see all of the cloud shadows, and it gives you this kind of three-dimensional view of some of the how high these cloud tops are and how they're kind of layered with respect to each other. The next image.
Okay, before you go on, I'm just going to say, if you haven't done it, you should go to our YouTube channel, which you can find through Griffith Observatory's website, and Patrick will teach you how to make Juno images just like these. Sorry, it's over there on my screen. It's actually not that hard. So you too can learn how to download these images from this spacecraft and make beautiful images like this. Okay,
yeah,
just
it's a great
do an advertisement for you, Patrick. There.
Thank you. It is a great citizen science project, and anyone can do it as long as they have a computer and some photo processing software. So,
which you can download for free.
Yes, indeed.
Yeah, and he teaches you how to do that too. So all is well. Everybody can do it. We'll look. Tweet us your pictures. We look forward to it. All right, go ahead to the next one.
So all these pictures are actually processed by the public. So they come in not looking like this, but in this image here, we're looking at Jupiter from an altitude of 4,300 miles. And you notice there's a white feature on the left there in that image. And we're going to go ahead and circle it because this series of images only took about 4 minutes to take from the leftmost picture to the rightmost picture. And you can see as we go to the next slide, we can follow that white feature there. It changes we're changing its perspective, and we can see what it looks like. It's a little different here in this center view. The next slide, here we can see that feature is really elongated cloud. In the next image, we were about the closest point to Jupiter. This image was taken just about 2,600 miles just above the cloud tops of Jupiter. This is the closest the spacecraft will ever get from the cloud tops of Jupiter. And here the spacecraft is traveling at 130,000 miles per hour. So it takes a feat to actually get an image like this, when it's whizzing just above the cloud tops at that speed, and trying to capture a still image of a cloud feature. In our next image, we're looking at a kind of swirly pattern here, and we're about 4,600 miles above the cloud tops of Jupiter. And someone asked a question actually during when we were planning our show, how big is that feature from this distance? Well, I went ahead and given the field of view of the camera, which is Juno camera, which is 58 degrees, I went ahead and calculated the diameter, and it turns out to be 228 miles. We're going to go ahead and put a circle around that, and then show that same region on a map centered around Los Angeles. And you can just gives you an idea of the scale of these cloud features of Juno. There's more on the Juno website. So if you go to Mission Juno, just type it in, you get to the Juno website where you can see more of these fantastic images from the Juno spacecraft.
Thank you, Patrick. So we've talked Venus, Jupiter, and in between, we have the asteroid belt. So Tony, I think you were going to tell us a little bit about some of our exploration of the asteroid belt.
Yeah, well, as we sit here, actually, spacecraft are exploring asteroids and even coming back with results. Over the last few years, both Japan and NASA, the United States, have been exploring two kind of different size asteroids, but asteroids that turn out to be similar in some ways. Japan explored Ryugu, which is a very tiny asteroid, and apparently succeeded in capturing some particles of it, which are now on their way back to Earth. And this will come back hopefully later this year when they're landed in the desert of Australia. And scientists will actually be able to see what Ryugu is actually made out of. And the United States is doing something similar with a larger asteroid called Bennu. Bennu is, actually, I don't remember the exact size. If anyone on the team knows it, that would be good. But it's of interest also because it could be a threat to the Earth in coming centuries. Not 4 centuries, but sometime in the kind of distant future, it might be something we have to deal with. So we want to learn as much about it as we can. Anyway, NASA is planning to also put a sampling probe on the surface and try to scoop up some particles, maybe a few ounces worth, and also send those back to Earth in about 3 years or so. Although the sampling actually should happen this month. So if they're successful, they'll do that. They'll have 3 chances to get samples if they have any problems on the way. So that should be really exciting this month. Not a lot of news about it yet, but I'm sure there will be, and some really neat stuff. But it's already making some interesting discoveries. And our main one we'll talk about is that we found pieces of another body that we've already studied, another asteroid, Vesta, which is it's the second biggest object in the asteroid belt. Ceres is the largest one, which is now classified as a dwarf planet. But Vesta was also visited by the same spacecraft that studied Ceres, the Dawn spacecraft. And we know the surface of Vesta very, very well. We've orbited it, mapped it, taken spectra of its surface, and we find some particles of it on Bennu. So apparently, through a complex system of things smashing into Vesta, particles traveling through the solar system, and finally getting scooped up, as part of the material that is glommed together to become Bennu. Some of it's recognizable, and we already know what some of the stuff is. We also find meteorites of Vesta on Earth. I think we have samples in our museum that someday you'll be able to see again. So that's exciting. I don't think anyone was really expecting this, and they actually really stand out. You can see they're much brighter than most of the material that Bennu is made of. But the way they reflect light is unique to otherwise to Vesta.
Great, thank you. Sorry, I was slow to get that picture up. So yeah, very, very distinctive.
Yeah, I've heard there was a press conference a couple of weeks ago about the prospects of what they would find, and there's about a 1% chance that some of the tiny particles of sand-like rock that they plan to get from Bennu could also be some of Vesta samples. So we'll see.
2 for 1, because we don't have a return mission to Vesta. So hey, great, pick it up by way of Bennu.
Yeah.
Okay, well, switching to something quite different. Tony always likes to fill us in on what's going on with launches and space exploration. And this was a very difficult week show to plan because there were a lot that was supposed to happen, didn't happen, and then things happened at different times. So Tony, why don't you clear it all up for us?
Well, let's talk about what did happen first. So we've been covering on All Space, SpaceX, we know of SpaceX with their Falcon 9 and becoming sort of the biggest launch supplier for satellites, and now even carrying NASA astronauts to the space station. But that's small fry compared to what they really want to do, which is get people on different planets in vast numbers, actually start, settling the solar system. Well, we'll see if that's actually possible. But to do that, you'd need a big rocket that's not too expensive. And we see the evolution of that actually happening in Texas. So for the last couple of years, SpaceX has built a huge factory there, and they're building these gigantic rockets that are going to lead to something called the Starship. Now, what this test was that went this week is a big tank. It's basically a fuel tank for a Starship. But these have to be able to take very high pressure, what are called cryogenic or, extremely cold liquid gases. And to test this one, they filled it to the brim with liquid nitrogen and then capped it off. So as it heated up, they just let the pressure build and build and build. And the idea of this was to find out when will this explode or at least burst. So it was supposed to do what you're about to see it do. So even though it does burst, it's not a failure. It actually just provides engineering information. And there it goes, pouring liquid nitrogen all over otherwise extremely hot Texas Southland there. And basically it failed exactly the way they wanted it to. And they're experimenting with different strengths of steel and stuff like that. Now, the whole idea of this is to lead to the Starship. This is actually the day after that explosion. You can see the top tank actually sort of was collapsed here, because that's where the failure happened, which is where they wanted it to happen, not ripping open the side or something like that. But in any case, what is also being built are 3 other big spacecraft. And here's one of them. This is the next one to launch. This is called, SN8. It's a test version of the Starship. And this is only part of it. Notice this one has wings on the bottom. And those are not fins like a Saturn V used to have or something. These are called flings. And as you can see, when it launches, these are going to be folded up, but they can move around. Like if a gust of wind hits it, they can respond and keep the rocket flying straight. Notice this has 3 engines. When it's fully up and running, this rocket will have 28 of these extremely powerful, what are called Raptor engines. But the next launch, instead of having just 1 rocket like we've seen, this one will have 3, and it's going to fly up to hopefully 15 kilometers. What's that, about pretty close to 10 miles or something like that, but high enough that if you were looking up at it, you probably couldn't see it when it's at the top of its flight. Then it will fall back down. Then it will do a belly flop maneuver using those flings and set it tail down so the rocket can reignite and set it down on a launch pad, as we've seen with the Falcon 9. The thing about this to remember is the top part of this, which will be attached probably in the next week or so, is big enough that if it were a full up finished Starship could carry up to 100 astronauts at once. Totally reusable. It's also going to have a lower stage that they're already building, identical construction except for the cargo part on the top, and it acts as a first stage for this upper Starship part. That's called the Super Heavy. So all this is being developed. Actually, NASA is interested in using Starship for carrying astronauts to the moon maybe as early as 2024. It's one of the 3 companies that's competing and still in the running for being the way that people land on the moon. So this stuff's really happening. And, you know, this can do some of the stuff the space shuttle did. It can carry up gigantic amounts of cargo. People are speculating you could even grab the Hubble Space Telescope with it and return it to Earth if you wanted to. So, I mean, people are dreaming up all kinds of things that Starship can do.
That's an amazing number, 100. 100. Kind of unbelievable. Or actually bending metal testing and, you know, having to fly a spacecraft like that.
I think anything except for maybe Werner von Braun's early experiments. I don't think there's anything like this where people are just trying out ideas and building it, see what happens, and then try the next step. So,
So moving away from, well, actually there's some SpaceX in this as well. Or no, I guess the next one. Tell me about some of the other launches.
Yeah, well, we didn't know what to do because there were all kinds of there were 4 big launches that we were looking forward to, all which could have happened just before the show. So this was the status of last night. One of them is the Blue Origin New Shepard. Now that's a small rocket, but it's totally reusable, and it's being developed really to carry passengers. It's developed by Jeff Bezos, most famous probably for Amazon, and he is also funding one of the development of one of the lunar landers that NASA is considering. So this flight was going to be to test the radar system for his lunar lander using his reusable New Shepard rocket, but that one got scrubbed at the last second and no rescheduling has happened yet. Antares was supposed to launch to the space station and got canceled. It was scheduled to launch today, and I'll tell you about that in a minute. Also, the Delta IV Heavy, which is the rocket you see on the right. I don't know if we have a separate slide for that or how this works. That one is carrying the Falcon. That was supposed to carry a big secret NROL-44, which is a spy satellite probably, and that one got within a couple seconds of launching now twice, and canceled just as flames were beginning to develop underneath it, and no rescheduling yet for that one.
Yeah, those 2 were kind of scary because you saw those flames and then nothing, and it looked like it was not good. But
yeah, it probably is not as bad as it looks. And actually, when a rocket shuts down and doesn't launch, it means that a computer or some sensor has sent something wrong. So it's good that it doesn't launch. But yes, it tends to make you come to the edge of the seat and bite your nails and stuff, because of course it's filled with explosives. Now,
so SpaceX also has a more contribution for us.
So then tonight there was also supposed to be 20 minutes after the possible launch of the Cygnus, a GPS satellite launched by Space Force. And GPS, of course, we all use with our cell phones. I mean, it is that GPS, but it is a military project. And Space Force now is in control of GPS. So this satellite got to within, tonight, it got to within, I think it was 2 seconds of launch or so, and scrubbed. So, and then they may try again tomorrow morning. The last I checked about an hour ago, SpaceX had not said what went wrong, so we don't know if they can do it with that fast a turnaround. SpaceX has another Falcon 9 sitting on the Pad 39A where they launched Bob and Doug from, with 60 more of their Starlink satellites. That's also scheduled to go tomorrow at 5:34 a.m. That launch, as far as I know, is still on. So, so did any of these things work? Well, we go to the next slide. Yes, one of them did work. So about 20, it was at 6:16 our time. The Antares rocket, which is now built by Northrop Grumman, carrying a supply module for the International Space Station called Cygnus, did successfully launch on its rescheduled time. So it's on its way to the space station. So as this email said, the curse has been lifted. Well, not completely, because 20 minutes later, SpaceX scrubbed their launch at the last second. But anyway, at least something's going somewhere.
Great.
So tomorrow, actually the next couple days could be, 3 launches right in a row or more, or, in Blue Origin reschedules. It could be a big, busy weekend or not.
That's the space exploration business.
Yeah.
Always unexpected. So, so Patrick, we're going to turn to you and ask you to tell us about the skies. I know we've already got that first one covered, and that is the moon coming close to Mars and that beautiful sight. I hope everybody got a chance to see it. So tell us a little bit more.
Oh, yes. So yeah, I mean, we saw. I hope you all went out and saw the Mars and Moon, close together, which was great over there in the east. And we're going to go to the next slide because Mars is very much in our story this month. And since April, it's been very dim. And these series of pictures, we see that Mars is getting bigger and bigger. And as it gets bigger, it appears brighter in our sky. That's why when you looked at it tonight, it was very much bright and right next to the moon. So Mars and Earth are getting close together. Let's look at the next slide. And its closest approach from Earth will occur on the 6th of this month, where it'll be 36.8 million miles away. So I encourage you to go out in the evening, take a look at Mars, and the light coming from Mars will be just about 3.5 light minutes. That's 3.5 minutes from the surface of Mars to get to your eye. Amazing. And then on the 13th, Mars goes into opposition. So let's go to the next slide. So this is still the series of pictures that we have. And I think the last picture is kind of middle of September here. And so as we get closer to Mars, how big will Mars get in our sky? Well, let's take a look here. Well,
there's a rumor as to how big, whenever Mars goes into opposition, roughly, because the orbits are slightly not round, but it's roughly as close to us as it gets in its orbit. So there's a rumor that goes around every time. And do you know what that rumor is?
Yeah, it was since the last opposition of 2003, which was one of the closest passes, closest minimum distance between Earth and Mars. Right after that, for a few years, people were getting in the email that if you at every kind of close approach in opposition, that if you were to look at Mars, it would be as big as the full moon.
So we're here to tell you it is not as big as the full moon. It will never be as big as the full moon. And if you went out and looked at the full moon tonight next to Mars, you know that's true. So Patrick, how do those sizes compare?
Well, it's actually in angular size when Mars is close to us. The moon is actually 72 times bigger than the angular diameter of Mars. So there we have it. Now, the only way you can actually see Mars as big as the moon, maybe one day our future astronauts will go there and it will be truly as big as the full moon. So, all right. So, yeah, what's all this about opposition? Well, opposition is if you draw a line from the sun through the Earth through Mars, you get an opposition. And in the next slide, we can see the distance of that opposition. And I'm going to turn to Tony because this opposition is very special especially for astrophotographers, and he can tell you, why astrophotographers and amateur astronomers and professional astronomers. Why are they all excited about this particular opposition?
Yeah, well, Mars is a unique planet in the sense that it's kind of Earth-like in that it has a thin atmosphere around it and you can see the surface, but enough to be dangerous. You might remember, reading in old astronomy books that 100 years ago or so, people were arguing about whether we were seeing signs of civilization in the changes that you could see on the dark markings of Mars. People were imagining lines on Mars, or were they? And there were big debates about who had better telescopes and who could see these things, and why other people with even bigger telescopes couldn't see them, and all kinds of stuff. And old history. Of course, now we know that there are no such things on the planet, but we do see dark markings sometimes, and we do see changes. Mars comes close only once every 2 years and 2 months. So it becomes a sport of amateur astronomers now to see how much detail we can see. And of course, we've got, armies of, or, fleets of spacecraft orbiting Mars. There's rovers on the surface. We can see Mars down to microscopic level, endlessly, if you look at various websites where the images are posted. But there still is both fascination and value in even amateur astronomers doing it. I'm starting to learn how to get images and stuff, and I just thought I'd share with you how technology's improved, and it might even be something you'd want to try. Like, if you want to try making color pictures of Jupiter, it's not that much different than getting pictures of Mars. So I'll show you how this happens. All right, well, you take a telescope and a video camera, and go ahead, if you could play this again.
I'm going to go back.
Yeah, go back.
Oh, I guess I have to go back to this one. We should have looked at it.
The file sizes were so huge. But you notice as you look at it, the atmosphere makes the image wiggle and blur and stuff. This happened to be a fairly steady night, but the thing is, as you see just the still image, you can see some detail, but maybe not as sharp as you'd like. Also, your eye can see more detail because your eye can follow those motions and stuff. So how do we improve on what the eye can see? Well, if we go to the next picture, what you can do is we use software that takes all those frames, and actually you shoot for about a minute or so and get several thousand frames. And the software helps you select which ones are the sharpest, and you can exclude the fuzzy ones. And then it will align all of these separate frames perfectly and make them kind of transparent so they all form an image made of thousands of frames. Then we put that image into another software called, the stacking one's called Auto Stackert. And then you can send it on, and there's all these German people are making these incredible software things, but they all work together, and you can actually get it to go immediately from one software to the other as it's processed. You don't have to do anything. You press a button after you've chosen your image, and maybe you sharpen it to taste, and then it does the rest. So it's actually semi-automated. Okay, let's go to the next picture. Then you put it in what's called Registax. Registax uses some of the same tools that were developed for sharpening Hubble Space Telescope images when it had distortion from the mirror bothering things. And you can, it gives you a lot of freedom as to how much detail and what kind of detail you can bring out. But you can see this is much, much sharper than what we started with. And I'm learning how to make it sharper and sharper. There's things like how well you can focus the telescope. It's a huge thing. How many frames can you stack, and various details like that. How steady was the air, actually still a factor. But you can get some interesting detail. So I'm going to show you what I've captured this month. This apparition, as it's called, the period of time when we can observe it. So way back in May, when Mars was far, far away, I started doing this. And actually, I have to just tell you, my results were so bad, I didn't think I could do it. But actually, just in the last week, I went back through those old pictures, and now I've learned enough that I was actually able to bring out some detail. So May, you can see the polar cap on the bottom. That's the south polar cap. Was pretty big because it was just coming out of spring, and that polar cap, you'll see picture by picture, start shrinking, and we can see dark markings on the side. June 17th, June 24th. August 16th, and notice, now it's coming rapidly towards the Earth, so it's growing a lot from picture to picture. The picture on September 7th shows probably one of the most familiar faces on Mars. Like if you see pictures of Mars, this is usually the favorite side to show. Now, I have to tell you, most people would turn this upside down because the convention for centuries has always been to put south at the top. But nowadays, people, been to the moon and stuff like that, and we don't see everything upside down. At least Northern Hemisphere people like putting north up. So that's how these are. South is at the bottom, north is up. But that big dark thing on the right is called Syrtis Major. It was the first thing seen on Mars. I think Christian Huygens was the discoverer of it, and actually was able to find the rotation period of Mars, 24 hours and 39 minutes, by watching it reappear. Then there's an arm-like thing on the left that's called Sinus Sebaeus, and a knot at the end of it called Sinus Meridiani, right near the left edge of Mars. And that's the zero longitude of Mars. So that's what scientists measure, the longitude of Mars. Okay, anyway, this is some of the detail. You can go on. So it continues coming closer. And as my skill improved a little bit, and also seeing improved and Mars is getting bigger, you can see more and more detail. So this view on September 13th, we're looking almost straight down on where the Curiosity rover is. Unfortunately, I couldn't find my slide that had everything marked out, but the Viking 2 lander is at the very top of this image. So, there's a way we kind of get used to seeing these through telescopes, but they're also familiar from their panoramas now that NASA spacecraft especially have returned. All right, we can go on. And here we see September 16th, September 25th. Now, the region in the middle, especially the view on the right of September 29th, it looks kind of like a claw just above the center. That's close to the region where the Valles Marineris is. So the huge canyon on Mars is in that region. I have to say, though, that the markings that we see through a telescope don't correspond very well to geographical features. So these are my most recent ones. Now, the air was terribly fuzzy, so it's not all my fault. But I tried something different on the right-hand view. They're actually taken the same night. The date changed between the two. But the one on the right, I enlarged it more. I used a thing that you use for enlarging images called a Barlow lens. Well, I stacked 2 of those together instead of just one, and it actually made the image twice as big, but I've shrunk them down. But you can see it actually shows quite a bit more detail. So image size, matching it to the camera is actually something you got to get down. All right, well, I'm stumbling around with it, but there are people that have really mastered this. Also, this is through a somewhat larger telescope. I'm using a 10-inch telescope in my backyard. Sebastian Voltmer has a 14-inch telescope, and he's been doing this for a long time. So he's one of the people. Damian Peach is another one, and our own Blake Estes, as we'll see later, are people who have really mastered shooting Mars from Earth. Now, I have to tell you, I was going to find an image by Damian Peach because I saw one a few days ago. It had a little bit of blur. It disappeared from Twitter, and it's because I'm quite sure. I mean, I haven't talked to these people, but he came out with a new one today that's even sharper, and I think it's because of this picture. So they're kind of competing with each other and trying to outdo one another. So there's that aspect of it too. Of course, the Hubble Space Telescope will show us what it really should look like through a telescope, and we'll get other views from orbiters and stuff. So anyway,
thank you, Tony. That's terrific, and so hopefully some people will be inspired to give it a try.
It's easy to do, and if you have you can even use DSLR cameras if they can shoot video. You can do this, So don't be afraid of it. It's actually fun to do and valuable. If a storm breaks out or something like that, you might see it before an orbiting spacecraft does.
Okay, so just to wrap up then, a few more things to see in the sky this month. Patrick?
Yeah, Thanks, Tony. That was amazing. So yeah, we can go to the next slide here. So in the so of course Mars is prominent in our evening sky, and it will be visible. It will start fading a little bit as the weeks go by. But something else you can see, and don't forget to look for it, is over in the south there in the evening sky. Just west of South, we see the planet, two planets. One is Saturn, and the bright planet is Jupiter. So we talked about the Juno spacecraft going around Jupiter, and there's loads of orbiting spacecraft and ground spacecraft on Mars as well. So this is what we have for our evening sky. Let's go to the next slide here to see something that. If you were up early this morning, you would have seen and looked for Venus. You would have seen it right next to the bright star Regulus in the constellation of Leo the Lion. It's only about half a degree or one moon diameter apart. So don't worry if you missed this morning, because tomorrow morning, go to the next slide, Venus will be just half a degree below the bright star Regulus. So if you have a camera, go out and see if you can photograph this rare conjunction between Regulus and Venus. It happens once every 8 years.
I love this because it really shows the difference the day makes. The stars are very far away, so they don't move. I mean, everything moves across the sky through the course of the night, but that's really showing, oops, wrong direction, how much Venus is moving in its orbit in a single day. It's pretty remarkable. And of course, you know, Venus is where Tannhäuser hangs out and Venusberg, so.
And we're looking at all those phosphine molecules.
All those phosphine molecules, yeah.
And also on Venus, on the 14th, the moon and Venus will be together in the east in the morning. So look for that. It's a pretty sight. So we look at the next slide. You can see the thin crescent moon. I think it's about 26 days old, just rising above the eastern horizon with brilliant Venus just a little bit higher.
So if you're like me and you go to bed late and get up late, try to switch it around, see the beautiful morning sky.
Yeah, I kind of hard for me to do that. I'm a night person. So speaking of night, being up at night, on the evening of the 20th to the morning of the 21st, there's our annual Orionid meteor shower, and the meteors originate just above the right shoulder of Orion, marked by the Orion radiant. And we go to the next slide, we can see the details of how many meteors you can see and what time to look for these meteors. You'll see a few bright fireballs from them. I've seen them in the past, and they kind of surprise you. The parent comet that produce all this dust that causes the meteors as we plow through the comet orbit is Comet Halley. All right, we go to the next slide, and we end up with our Halloween-themed pumpkin moon phase table here. And we can see all the principal moon phases identified here. But I want to point out two things are special about this moon phase calendar. On the 1st of October, which already happened, we had a full moon. But if you look at the end of the month, there's another full moon. So 2 full moons in a month. The second full moon is a blue moon, in this case, a blue full moon pumpkin. So that's kind of special.
Yeah.
What?
So is it really blue?
Well, actually, if we look at the next slide, I kind of made a kind of a illustration of what that might look like. Not quite blue, but if you happen to be out trick-or-treating under the light of the full moon, make sure that that light of the full moon will hopefully illuminate your way to all those special treats.
Safely. I'm not sure what the rules are. We had a conversation the other day about wanting to be sure we knew, and it's in different places, different policies. So make sure you know what the safe situation is for your loved ones, your little ones, to go out and get those treats. Or your big ones. You know, Patrick goes trick-or-treating every year, beats the kids back to get to the candy, right?
I'm just going to go out and look for the moon and Mars.
Yeah, beautiful. So with that, I want to share some personal news, and then we're going to go to our pretty pictures section. My personal news is that I'm going to take the city up on its retirement buyout, and I will be retiring, which is kind of exciting. More than kind of, it's totally exciting, but also sad because that means I won't be here to do All Space Considered anymore. So I'm particularly sad because there are many of you who have come back regularly. I have so looked forward to seeing you every first Friday of the month, and have such affection and gratitude to you for being friends as well as audience members and patrons of the observatory. So that's part of why I was being fishy earlier about we don't quite know what's happening on the November show, because I don't have my retirement date. They've accepted my paperwork and I know that I'm retiring. I just don't know when. The city has to tell me. So I just don't know, and it is possible this is the last one. So I did want to take a moment and say goodbye and say thank you, and I hope we meet again. And so that's my little announcement for tonight. So I will be indulging myself in the second half a little bit on a subject. Obviously, we talked a little bit earlier about what we're going to dive into, but I thought it was an opportunity to share something about which I care a great deal. And so when we come back, we'll be talking about what's happening to our atmosphere and our planet. So with that, we have a series of pretty pictures. At this time, usually in the show, if you came into the theater, we turn down the lights. And so you might want to do the same. And then we're going to take a short break, about a 6 or 7 minute break with a couple very beautiful videos. You may not want to take a break because they're so pretty. And then we'll be back for part 2. So again, thank you again. And follow me on Twitter so that I don't lose touch with you. I'll think of something to tweet. All right. So with that, lights down, and we'll go forward with these pretty pictures. This, of course, is the first one, taken by the observatory's own Jared Donkersley, and of our favorite observatory, Griffith Observatory, and that beautiful, stunning full moon. This first bunch are all from observatory staff. This is from David Pinsky. That's a moonrise, and it's so red because it was happening, it's early October, I think it was around the 3rd or 4th. It was before the Bobcat fire, but that actually is smoke that's being off to the east from the El Dorado fire. And then later that night, this shot of that beautiful, beautiful full moon. Oh, I guess there's another one. Can't get enough of David Pinsky's photography. This was sent to us by a fellow in New Jersey who often sends us photographs, and we're grateful to him for that. Let me get his name back up there. That's actually, you can see, obviously taken on September 11th, and the blue beams cross right in front of Jupiter. It's a beautiful shot, and we thank him for it. And let's see here what's happening. There we go. More David Pinsky. Oh, this was just the other day, a couple of days ago, and I think there's something in the corner, but if either of you can fill in, let me know. But
we can see an object straight above it. It's probably Jupiter.
Okay. And yeah, more David picture. This was International Observe the Moon night last week, so we have a number of pictures of the moon through telescopes. And this one from Blake Estes, we mentioned Blake earlier. And Tony, I think you know this is through Mount Wilson, is it not?
That's right. Yeah, these are images taken with a 60-inch telescope at Mount Wilson. And so obviously they're stunning detail. Although he's using techniques similar to what I should do. I mean, he actually showed me how to start doing this stuff. But he is a absolute master of it, and even Hubble Space Telescope is sometimes rescheduled what they're doing based on his pictures like of Neptune.
And Blake is an observatory staff member, one of Tony's telescope demonstrators. So you don't often use a 60-inch telescope to look at the moon, but he did. He's also works at Mount Wilson. So this one from our own Tony. What a gorgeous shot, Tony, on International Observed Moon. And just, this is not the moon. This is the International Space Station, unbelievably crossing in front of Mars. Just a crazy picture.
Yeah.
But Blake caught it, or pardon me, not Blake. Jared caught the International Space Station in front of the moon. There we go.
Yep.
This is another Tony.
Yeah, and that's the shadow of Ganymede. And if you look below, slightly to the left, right at the edge of Jupiter, you can see the red spot just beginning to come into view.
This is shows the evolution of a storm. You can see the planet rotating, and you can see above it in the northern. Oh, I have a pointer over here. In the northern hemisphere, not unlike what Patrick was talking about, how storms evolve. You can see this white feature that just gets stretched out and stretched out and stretched out as Jupiter turns. These are Blake's pictures of Mars.
Oh, and these are with the 60-inch telescope too. And actually, I think they're the last pictures he took before something happened that we're going to be talking about.
Something happened to Mount Wilson.
He had to leave the mountain quickly.
Yeah. On a personal note, I actually, on that 2003 close approach you talked about, I was fortunate enough to be look through the 60-inch. It was pretty exciting. And then here's some pictures from Anthony Persich, who's one of our telescope demonstrator. Absolutely beautiful images. North American Nebula should be familiar to some. And double cluster. And yeah, the label is covered up on my thing. And everybody's favorite, the Pleiades. Beautiful. These are images you can take yourself. That is dust reflecting the blue light from hot stars. And the Orion Nebula and associated nebulae, all in that star formation region. And so we had a couple other people send us some images of that. This was tweeted and we grabbed it. I actually understand this gentleman watches All Space Considered. He said something to that effect. So what a beautiful picture. It was during the smoky days of September, and that again, everybody's favorite observatory, she says with great bias. These are not astronomical, but they look kind of astronomical. I love it. It looks like it could be a nebula, but these are flowers in the ultraviolet. So just like we saw Venus in ultraviolet, you can look at things on Earth in ultraviolet light. And this is what these are a couple of pictures of flowers viewed in ultraviolet light. And finally, let's see here. Oh, yes, half dome. Have to show that. That's kind of insane. We will come to more of that later. And Sarah, could you join us and tell us what this is all about?
Absolutely. So for the last 12 years, the Royal Observatory Greenwich has hosted a competition called the Insight Investment Astronomy Photographer of the Year competition. And for the last several years, we've shared the winners of this competition because they're absolutely gorgeous. This year, there were 5,000 entries, so the competition got pretty fierce. I'm going to show you the overall winners of all the categories because they're amazing.
And I'm just going to say, may I, Sarah? We're losing Sarah. Well, life has changed for everybody. Sarah is leaving Griffith Observatory to go to the Planetary Society as their, what is the exact title? I know it's like a media manager.
Yeah, I'm their new digital community manager, which is absolutely amazing. And I know I wouldn't have been able to get to that place without all the experience I've had on All Space. So I'm super grateful for everything, and I'm going to miss all of you so much.
I miss you too. Sarah has frequently told us stories of citizen science, ways in which you can do different scientific projects. That's one of her specialties. So we know you're going to be fantastic at the Planetary Society, and we'll miss you too.
Thanks, Dr. Danley.
Okay, on to pictures.
Pretty pictures. All right, so this one right here is called Painting the Sky. It was captured by a man named Thomas Kast in Germany. This image was taken in the Finnish Lapland. What you're seeing here are actually a type of cloud called ice polar stratospheric clouds, or nacreous clouds, which are, they exist really high up in the atmosphere and only happen when it's super duper cold. And in order to see them, it's best to look for them at dawn or dusk, when the sun is below the horizon and can light the atmosphere, but not the ground. So you get these beautiful rainbow colors in the sky. This is a really great image. This one is called Liquid Sunshine. It was taken by Alexandra Hart in the UK. It's a really close-up image of the sun, but for some context, these convection cells in the sun are actually about 600 miles or 1,000 kilometers across. So it kind of gives you a good perspective, not only on how big our sun is, but how pretty it is.
And from the sun to the moon?
Yeah, this one's really cool. It's called Tycho Crater Region with Colors, because obviously it's a picture of Tycho Crater with pretty colors. It was taken by Elaine Pilot from France. In order to get this image, they actually took 2 pictures, the first one in black and white to get like really good details on the craters. Then they took a second image in color and then combined the 2 images and dialed up the saturation on the colors so you can really see the difference in the terrain. That blue color is caused by titanium oxide, while the reddish color is caused by iron oxide. So you can see the variation in the soil on the moon.
So those are real colors, just saturated, super saturated.
Yeah, you wouldn't be able to see that with your eyes, but you know, if you turn it up on Photoshop, you can really get the good details. This one's really pretty. It's called The Green Lady by Nicholas Rammelt from Germany. He actually captured this while he was on a trip in Norway and had been trying to get a picture of this aurora phenomenon called the Lady in Green for a while. And you can kind of see why it's called that. These cascading green aurorae kind of look like the unfurling of a skirt. So it's really pretty.
Or the rising of a phoenix.
Yeah, I could see that. Green phoenix.
Yeah.
This one is cool. It's called The Space Between Us. And in order to capture this, they had to wait for an alignment of the moon and Jupiter. This actually happened last year on Halloween, on the 31st of October, 2019. And you can see the moon on one side and then Jupiter up in the corner. And if you zoom into Jupiter in this next image, there's actually 3 little dots around it, which I put labels on so you can see 3 of the moons of Jupiter. Can you forward? Yeah.
Mm-hmm. Oh, sorry.
Yeah, there we go, little moons. So that's an image that's pretty difficult to capture. You have to wait for exactly the right time, and it was really well done.
It must be done on video too.
Probably, in order to get those like sharp details.
You have to stack it. And,
yeah.
Oh, you're back to that one, okay? Yes.
Mm-hmm. Yeah. So this is a kind of provocative image. It's called The Prison of Technology. So right there in the center, you can see the double star Albireo, but all around it, these kind of streaky lines, those are caused by moving satellites that have gone through this image while they were trying to take the exposure. And I don't know, maybe a lot of you are familiar with the fact that over the last year, SpaceX has launched an incredible number of satellites for their Starlink constellation. It's supposed to give everyone, you know, internet all around the world, which is super important. But at the same time, this image kind of asks us to think about how our advances in technology impact our ability to look at space. So, you know, kind of interesting and scary. All right, this one is called The Cosmic Inferno. It was taken by Peter Ward in Australia. I don't know, it was kind of sad, but also provocative. Peter Ward, you know, as many people in Australia did, they experienced those massive wildfires at the end of 2019 and early 2020. And he wanted to capture an image that kind of evoked that feeling of the fire. So we got this image of a nebula. It's called NGC 3576. You can see it in the southern skies. You won't be able to see it from LA. Then he took this image and used computer processing to remove all of the stars. So all you see is the gas and dust of this nebula. So this fiery image kind of asks us to think about our planet and how precious it is and how we need to protect it, which I think a lot of us can relate to here in California as we deal with these fires. All right, this one comes from the prize section for the best newcomer. It's called Waves by Bence Toth from Hungary. It's of the California Nebula, and they thought that this part of the nebula kind of looked like rolling waves on an ocean during the storm. Really pretty. This one's a little different. So this image is called Dark River by Julie Hill from the UK. What they did was they got an image that was taken by the Vista Survey Telescope, which is part of the ESO's Paranel Observatory in Chile. And it's a huge image. It's like a gigapixel, and it contains 84 million stars. So they took this image, they printed the whole thing out, and then they crumpled it into this kind of, statue-like structure that they thought looked like the cascading of a river of stars. Really interesting submission. This one I think is my favorite. It's the winner of the Young Astrophotographer section of this competition. The image is called The Four Planets and the Moon, which was taken by Alice Fock Hang on Reunion Island, which is in the Indian Ocean. Alice was only 10 years old when she captured this image. Really, really admirable. You could see 4 planets, Saturn, Jupiter, Mercury, and Venus, along with the Milky Way, the star Antares, and the setting crescent moon over the Indian Ocean. All right. And this next image is the last image of the set. It is the winner of the Galaxy section, but also the overall winner for the whole competition. And it's called Andromeda Galaxy at Arm's Length. It's taken by Nicolas Lafadu from France. In the center, you can see the Andromeda Galaxy, but they used an interesting camera technique called tilt shifting, where you angle the camera lens so that it defocuses the foreground and the background, but leaves the center in focus. In this image, it kind of gives you the illusion that you could just reach out and pick up the Andromeda Galaxy with your hands, which is really cool. But in fact, the Andromeda Galaxy, despite being our closest neighboring galaxy, is over 2 million light years away. So this image, I've kept it as my background on my computer for a long time. It's really beautiful, and I think it kind of evokes that feeling of connectedness to all of our stellar neighbors. So I love it. But that's the last image of this competition. And if you're interested in getting your astrophotography into this competition, go ahead online and check out the Insight Investment Astronomy Photographer of the Year competition. Next year's competition submissions start in January 2021. So you can participate as well.
Well, thank you very much. Appreciate that, Sarah. And now we're going to take a little bit of a break. We have, as I mentioned, some absolutely beautiful videos. This is meant to give you a chance to go to the refrigerator or the wine cabinet or wherever it is you go to get ready for part 2, which is going to be quite a bit shorter. I think with David gone, we knew we had a little more time, so we were a little more really relaxed, and it looks like we relaxed a little bit much. That's totally fine, though. I'm happy to have spend this time with you guys and with you out there. So enjoy break videos, and we will see you in about 6.5 minutes or thereabouts. All right, so on we go. Okay, welcome back, everyone. Hope you got some nice refreshment. And we are back to part 2 of All Space Considered, sponsored by Griffith Observatory, not from Griffith Observatory. So let me just jump right in. We have a bunch of new things to share. Mainly, we're going to be talking about Earth in this half. And in particular California and what we're experiencing here in California and how it may also be affecting the rest of the world. So with that, I am going to get started. Just as a reminder, our second half is really about Mount Wilson, fires, heat, drought, and then trying to understand really what the causes are and what's the solution. Are we doomed to experience this more and perhaps even worse in the years to come? So let's start, as we often do, with Patrick to talk a little bit about the temperatures we've been experiencing. It has been exceedingly hot.
Yeah, it was scorcher last month at the very beginning. You can see on the 6th of last month, there was excessive heat warnings throughout basically all of California. And we experienced it right here in Los Angeles and the surrounding communities. So we go to the next slide here. And look at this. Here's a tweet from the Woodland Hills, 121 degrees. That was an all-time high. You only experience this in Death Valley or out there in Arizona somewhere, but this was exceedingly high. And there were health warnings, cooling centers were open. There were also power alerts as well. People had the air conditioning cranked up high, and there were some rolling blackouts that were in effect during that day. We see some of the other records, like downtown LA got to 109. I mean, that's a record. The last time you can see there was 1955, 102. And other places had record high temperatures. Just exceedingly hot. I think one of the hottest I've known. Even in Burbank, it was 117 on that day. It was just unbelievably. I just couldn't believe it. It can get that hot, but it did. So, and you can see not only did California experience the heat, there was a lot of heat around the western states, and this temperature map actually shows the extent of how hot it was throughout the west. Except if you live right on the coast, even though the coast was a little bit warmer than normal. So we can go to the next slide.
Well, I was just going to say on this one that I used to live in Colorado. And, they always say in Colorado, if you don't like the weather, just wait an hour. And this was particularly true this past month. And when we saw this.
Yeah, this happened 2 days later after we had our big heat wave. And so, in Denver, it started out as 93 degrees as a high one day. And then 2 days later, there was a 61-degree temperature drop. And it was 32 degrees and it was snowing. I heard this over the radio and I was going, what's going on? First the heat and now the rapid cooling. Actually in Denver. So that was something of a surprise. But I know that this area does experience these huge temperature drops. But I think this might be one of the ones on the record for a big temperature drop over 2 days.
So Patrick, what caused this terrible heat?
Yeah, we can. We'll find out the culprit. The culprit is high pressure, and high pressure is good for us in the winter because it keeps us dry and kind of a little bit warm. But in the summer, it can cause heat waves. Basically, it's a dome of air. And the air descends in high pressure, that's why it's high pressure, higher than normal, to the surface. And when it does, it compresses and it kind of gives you that heat. And the heat can give you the big heat wave that we saw on that earlier map with the big red region here. So on the same day, you can see the extent of this high pressure. And I've kind of indicated the western states. It's all over the western states. They experienced record high heat. And yeah, this happens with high pressure. And something else that high pressure does is that it suppresses the monsoon season, which normally occurs from June 15th through to September 30th over in the southwestern states like Arizona and New Mexico. And they normally get lots of thunderstorms, which gives them a cooling period. But this year they have seen very little rain and the monsoon seems to be not there. In fact, there's a poster for the missing monsoon. So where is it? Typically monsoons give us, particularly in Phoenix and northern Arizona, a lot of needed rain that they in the summer, and it can be in Phoenix up to on average about 2 to about 4 inches of rain. And in the northern areas, just about 4 to 8 inches of rain, which replenishes the reservoirs. But this year in Phoenix, they were supposed to get around about on average 2.78 inches of rain, which is a normal monsoon season. But this year in its monsoon season, which has just ended, they only got 0.46 inches of rain. And this is because that the high pressure, which normally is not present during the monsoon season, draws moisture from the eastern Pacific. And so with the high pressure in the way, it basically all the storms are diverted around. It's just like, you know, seeing a rock and then seeing all the water go around the rock. That's what high pressure does. So that's why it got dry this year, and there wasn't much of a monsoon season. So it's all high pressure's fault. And here are just some of the temperature records in the absence of the monsoon. And what does this mean? Well, it means that Arizona was put into drought because of the lack of rain, and things just got drier. Go to the next slide to see the September 17th. It got a little bit better in September. Actually, that was last year. Compared to last year, it was better. So as a result of the high pressure system, we can just go step through and look at the western states just month by month and just see how dry it's getting. So you can see all the red and the orange building up over the Four Corner States area and even over in Nevada as well. So here we are on September 22nd. I think we have another one to go, and you can see it's just drying up very much. So a lot of the state is in Arizona, and most particularly, almost all of Utah is in a extreme drought at this time. Taking a look at our own state of California, compared to last year, we were in good shape. And this is what there was only a little bit of a dryness over in the southern part of our state. But if we fast forward to September 22nd this year, we can see we're not in so good state. And a week later, if you look at the northern end of our state, it's we're beginning to see some of the next slide, extreme drought creeping in there. Luckily for Los Angeles and the local area, we got a lot of rain in this area, so we're still not in the drought.
So, of course, with these conditions, this is a problem in the making, and I'd like to ask Angelica to join us, please. Angelica is yet another one of our wonderful staff members who's done a lot of work to help build the program tonight. And so we're going to tell you a little bit about one of the terrible consequences of this big drought that we've been experiencing and the high temperatures we've been experiencing. And that, of course, is the terrible fire season that we've been experiencing. Last year, as I mentioned, last year, feels like it, doesn't it? Last month, just a month ago, we were telling you all about the fires at Lick Observatory, and you know, thought we were done, but no, we had to have little competition from Mount Wilson also then threatened. This happened just 2 days after our last All Space Considered. So Angelica, I think we'll ask you to tell us a little bit about it. We know it just started on the 6th, and just 2 days after our last All Space Considered. So tell us what happened.
Well, we, lovers and supporters of Mount Wilson were eagerly watching the Twitter feed for updates.
And, I'm going to interrupt you, Angelica, because your sound is not very good. Can you get closer to the mic or do something that will? Yeah, that's much better. Thank you. So you'll be, for any of you that saw that Princess Bride where, Buttercup was holding her. If you don't know what I'm talking about, I'm always.
Right.
Go ahead.
So all of us who love Mount Wilson were watching the Twitter feed, and with a lot of anxiety. It began September 6th with a notification from the Angeles National Forest that there was a fire just of 200 acres at the time, but rapidly burning. And Mount Wilson quote tweeted this with just to say, "Here we go again," because for fans of the HP Wren live cam, we've been watching a lot of fires from Mount Wilson. We had the Apple Fire in the San Bernardino Mountains. There was a ranch fire not too far away in the Azusa in the San Gabriel Mountains in August, not even a month away.
Angelica, I'm sorry, your sound is very poor. You're going to have to hold it up to speak because we can't hear you.
Okay. So as I was saying, here we go again, because in August we were looking at the Apple Fire in San Bernardino and the ranch fire in Azusa from Mount Wilson. So this was this was pretty familiar territory, Mount Wilson. But by that evening, things were looking pretty serious. It was coming closer, and the staff at Mount Wilson Observatory were kind of awaiting evacuation orders that night. The next morning, the next day, CAL FIRE did indeed order an evacuation.
And I think we mentioned earlier, Tony mentioned that picture that Blake took was maybe his last picture before he was very hurriedly asked to leave the mountain. Blake,
and by the way, that's the 60-inch telescope right in the center of this view, and the 100-inch is off on the left.
And in fact, Angelica mentioned the HP Wren, and we're going to be showing a lot of pictures from this. And in fact, if you watch the break video, you saw images taken from that camera. It's on a tower, has images north, south, east, west, all the way around. So you get a panorama of the entire mountain from that camera. So that when we say HP Wren camera, that's what we're talking about, that camera on that tall mount. Okay, so we had to evacuate.
Yeah.
They had to evacuate. Blake had to evacuate, and just about everyone except 3 people on the mountain. Only 3 were left.
Skeletal crew was left. It was a scary night. Next morning, they survived the night. Things, however, were still very, very tense. The fire did rapidly grow. By September 10th, we were looking at over 23,000 acres with 0% containment. So a lot of just the worst conditions possible. It was looking really, really dire.
Angelica, you could see it from your home. In fact, both you and Angelica and Tony, you could see it from your home because you live on the east end there.
Yes, I'm happy to represent the San Gabriel Valley. And if we look at our next slide, I got to live in some of this smoke. I saw the fires from my backyard at night.
I love this particular one because it's like a perfect outline of mountains, and they're just all on fire.
Yeah.
What a spectacular slide from Christie. Just fantastic.
Mm-hmm.
So that led to
me staying inside, and a lot of us staying inside because it was, ash everywhere, smell of smoke everywhere. The conditions were not quite the bright orange we saw in the Bay Area, but pretty apocalyptic by my standards. Just to let you know, red is bad, purple's really bad. So we were all advised to stay inside, avoid activity. That's the air quality index there. Heavy artillery is called in. Something like 12 companies from the LA County Fire Department have responded to Mount Wilson. It was where they were going to make their last stand on this. Things were getting battlefield conditions. This now iconic image here, shared throughout many news organizations, front page news there, this image.
So within 1 week, it went from 200 acre small little fire to this raging inferno threatening the observatory.
Yes. Knocking on their door, really, by the 14th here, looking east. They were predicting it to come up to Mount Wilson from Echo Rock. All the personnel had been evacuated by this point. It was looking as scary as we'd ever seen it. And yet September 15th lived to see another day. Fire came within 500 feet. And it was the big headline news. It was something that a lot of us in Southern California, especially those of us who were born and raised here, were really concerned about.
And they actually tweeted, we got the all clear. And I retweeted it. It's like, oh, phew, okay, the worst of it's over.
Yeah.
So we thought.
Well, fires like to hear that, right? They like to hear, oh, they're good now. But fires will do what they do. So by the 16th, we're looking at flare-ups again. Fire's getting close. Things are looking scary. I believe we have Sam Hale.
These two maps side by side were just 29 hours apart. There's this one from the 16th, as you mentioned, and then by the morning of the 18th, you see it's 12:30 in the morning. It had engulfed. If you look again, you can see the road of Mount Wilson, and this road down here. This is all the site where those telescopes are, and the snow telescope. And by the morning, early morning, 12:30 in the morning on the 18th, that was engulfed, and we were very, very worried.
And we didn't know anything. We didn't know about the monastery. We knew nothing. Right. Yeah.
All of the personnel were gone, and so it was. And this was the view on the H-Run camera, or the tower camera. So we were all horribly worried. Now, I will say that I had the marvelous opportunity, and I said this at the opening, to talk to Sam Hale, who is the grandson of George Ellery Hale. If you were an astronomer, you know who George Ellery Hale is. He was the founder of Mount Wilson Observatory, built the 60-inch, the 100-inch, the Palomar telescope, Yerkes, really just the pioneer who brought astronomy to Southern California. So his grandson.
He gave advice to Colonel Griffith too about building a telescope for the city that we know, Griffith Observatory.
Yeah. What observatory? So as I mentioned, I had a marvelous opportunity to speak to him, and we have posted that full interview on our YouTube channel, and you can see it, and I hope you'll go watch it in full. But we're going to do a little excerpt here. That one I think is about 17 minutes long. We're going to just do a 3-minute segment right now, so you can hear Sam talk about his beloved observatory and what happened. This has been a really traumatic month for Mount Wilson Observatory. How was this experience for you, watching the observatory under such threat?
It was hair-raising. This is the third time in the last decade we've had to face a fire. Somebody said it got within 20 feet, and then the flames actually licked the top of the monastery.
Terrifying.
It's especially important to me and dear to my heart because so much of my grandfather's books are in there. And there's a wonderful picture in there, you might recall, of Einstein sitting in a chair, and surrounding him there's Hubble, there's Walter Adams, who followed my grandfather as the director of the Mount Wilson Observatory. And then we have what we know as the Einstein chair. So anybody who comes gets to sit in the chair that Einstein was sitting in when that photograph was taken, probably in 1931. I hope you had a chance to sit in the
I
Einstein.
did sit in Einstein's chair, and someone
Did you feel a little tingle and inspiration?
I was wondering if they grabbed Einstein's chair and evacuated it off the.
Laura, I asked that exact question. I said, did you get that picture? And did you get that chair? And Larry Webster told me, who is really the one that oversees all of the memorabilia there. He said, we didn't have time to. But what the firefighters did was put what they call a fire blanket over the windows. So the heat from the fire wouldn't penetrate. They went in after this called the Southern Onslaught, and everything was fine. These guys who were firefighters, who were on the mountain, they are just beyond incredible. First of all, the bravery that they have to do what they're doing, you know, the physical exertion. Not only are you in this huge fire suit with this big helmet on, a big pack, dragging around these heavy hoses, and some of these slopes they get on, I mean, they're more mountain goat than they are human, I think, the way they can do it. And they are so professional. I mean, I'm speechless. They're so wonderful. And they did the same thing 11 years ago for the station fire. And, you know, we wouldn't be talking about this today, this good outcome, if it wasn't for that. So, and wonderfully enough, Tom Minigini, our executive director, just sent me some pictures, and he had a bunch of the firefighters up in the 60-inch, letting them look through it, look at the stars.
That's so wonderful. I was going to say that, you know, when this is over.
Let me tell you, we are going to have so many firefighters up there for a huge thank you.
So we will absolutely encourage people to go and donate what they can. And it's such a national and local astronomy heritage site. And Sam, I'm so grateful for your time.
Absolutely. Thank you for letting me join you and share this with all your viewers.
So indeed, thanks to Sam. And you heard Angelica mention the monastery, and Sam mentioned the monastery. In the long one, I thought he described here, but in the long one, he tells you what the monastery is. But you get the gist because you saw the picture inside the monastery. The monastery had that name because it used to be that only men were allowed there. Margaret Burbage broke that, I guess what we call it, it wasn't a glass ceiling, but that taboo. The monastery is an historic building where all the astronomers slept and ate and lived when they were on the mountain, like Hubble, like Einstein when he visited Hubble. So the monastery is just of tremendous historical importance. And as you can see here, and as he said, the flames did actually leap onto the roof of the monastery, just like in that picture where the perimeter engulfed it. So we have a little bit of video. They posted this on the 28th. So, you know, much, much later, 11 days later, until we knew what and got to see this footage. So here it is. And now slowed down, burning the roof of the monastery. So,
yes.
Did you want, yeah.
Oh, go ahead.
Go ahead.
Okay. Just to speak to this tweet right here, because the watchers on the HP RAN were probably pretty scared when they saw fires continuing to be very close to the observatory. These were actually backfires, so this was part of the combat strategy to save Mount Wilson Observatory here. So for those watching the cameras, remain calm. And a lot of people were watching those cameras.
Yeah, and Tony tweeted it as well that it's a backfire, and that's also in the video. Sam describes in the longer one. Sam describes his anxiety when he saw that, and then Tom, the mountain director, the director of the observatory, called him on the phone and said, actually, I think Sam called Tom, and Tom said, "Look at the trees in the foreground. All of the flames there's sort of one set of trees on this side. It was all backfire." Tony, did you have something to add to that?
Well, also what you can't see in that picture very well, next to the 100-inch, the Chara array, which is a modern instrument for getting images actually of star diameters and stuff. and it covers half a kilometer around the 100-inch telescope, and that's very, very close to the control building. My daughter actually runs a telescope right in that area, so we thought it was fried. Unfortunately, it's not communicating with us right now. It has a computer problem, so which happened before this. We were actually about to go up to try to fix it.
Yeah.
And so we still don't know its condition yet, but I'll be going up there soon, actually.
Yeah, if people listening have not been to Mount Wilson, I mean, you can't go there now. Hopefully, maybe there will be an opportunity before the end of the, before the snow comes and makes it inaccessible, to just go up and hike in that area. I doubt, with all the fires, and we've only got about a month and a half before the precipitation starts to come in, but it's so worth it. And for sure next year when they start resuming their programming, they've got lectures and music and all kinds of great stuff going on. So the good news is that there have been a couple flare-ups here and there, but it's the like you said, do I dare say the worst is over? Do we want to tempt fate? I don't know. But as I say, occasionally they're still dropping some retardant on there just to stop the advancement or make sure things are fully out. And then here are some of the pictures that Sam referenced about the firefighters going and looking through this fantastically historic telescope. So I really look forward to that day when they have the big party. I'm gonna see what I can do to get invited to that party, because that seems like that's going to be pretty fantastic. So yeah.
I was going to say they were the next to look through it after Blake took his Mars.
Good point. So the fire still burns. Angelica, you want to say a few quick words about this?
Yes, this is a great map because the colors actually represent the timeline. So blue would be where it started, and then going on through the spectrum, green, yellow, and the deepest red being the latest fire. And so you could actually see how it went north towards the Antelope Valley, where it is currently at 79% containment.
So a huge improvement from where it was, because that also in that period from the 15th to the 17th, it went from 6% containment back down to 3% containment. It's like, wait, that number's supposed to go up, not down.
Yeah.
So a few quick last comments. One is that it was kind of quickly went through that, but they have a GoFundMe site. And so if you are a fan of astronomy or history or Los Angeles, Sam tells the story where they've spent a lot of their reserves, fortunately, putting into place before fire season, water tanks, new hydrants. He said the firefighters were astonished that there was so much water, and it was all because the foundation that runs the institute spent the money and spent their reserves because we know this is coming, and so they thought this was absolutely essential infrastructure upgrade, and it was. So they are depleted badly and are in need of support. So we hope you'll think about going to this GoFundMe site. You can just type GoFundMe Mount Wilson, you'll find it. So think about our amazing neighbors. Oh, Brendan, do you have a question?
Yeah, well, one question I think that should be asked, of course, is, well, what about Griffith Observatory? Was that at risk during these fires? Is it still at risk? What's the status on our observatory that we love so much?
Tony, you want to take that?
Well, of course, Griffith Observatory is, I think as the crow flies, something about 12 miles or so from Mount Wilson. And we have a lot of city in between Mount Wilson and Griffith. So the Bobcat fire was no threat other than to our lungs at Griffith Observatory. However, Griffith Park is also very dried out. And some summers we do have huge fires. So not from the Bobcat fire, but it has been endangered before. 2007, we had a huge fire in the park. Didn't directly threaten the observatory, but it could have, if the fire department had not been on top of it.
So thanks, Brendan. Going to move quickly through some fire things just to talk about this season. We are fully aware that this has been a very bad fire season. I like this map because it just, you know, shows the string of fires up and down the western states, and another view of kind of the same data as of yesterday. So that was more updated. And in particular, 5 of the cities, pardon me, the state, California's worst fires have all been part of this fire season. This was a seriously bad fire season. So here are the stats for California, 3.7 million acres. You can read as well as I can. Just a very, very bad. You can get these data updated on CAL FIRE. But when you put in Oregon, California, and Washington, you can see the acreage goes up to 5.4, and I actually thought I saw a higher number than that. So, you know, things have been, they are changing quickly because the fires are still raging. The incidence there refers to now large fires and only since July 1st. So it's a different data source than the California one, which is why that number is lower. But you can see there's quite a lot of loss. And just the cost of fighting the fires, 1.4 billion in suppression cost. And that doesn't take into account the property damage, you know, people having to evacuate, the animals lost, all the rest. So there is no doubt, no question, but that these fires are incredibly damaging and destructive, and we have to get a hold of this. We can't be having this be our summer every fire season. We still have a month and a half left of fire season. So, in addition to, of course, the actual fires and flames, as Angelica mentioned, is the air quality. And there have been, I've seen some numbers, I don't want to quote them because I can't verify them, but of deaths attributed to lung complications of lung disease in these very trying circumstances. I think I showed this picture earlier. It's a wonderful picture and pretty pictures, but you can see it's not a pretty reason. The air quality here in Los Angeles was terrible. The other one is for Oregon, in Salem, and around the Oregon fires were even worse. Just unbreathable air, just horrible. And of course, what happens when there's all this smoke in the, we've heard Angelica mention, we saw these pictures from Northern California, just looking eerie as all get out. This one was 9 o'clock in the morning in San Francisco. That was not sunset or anything like that. It was morning. This crazy one, actually these crazy two, well, I'm going to have to say they're not exactly both San Francisco. Only one is San Francisco. I think you can recognize which. The other is from Blade Runner. And I remember hearing someone who, you know, we live in California, it's an industry town, talking about, oh, nobody is going to believe that as, you know, that Blade Runner, because when they made the artistic choice to make that look like that. So maybe it's not so far-fetched. Here's just another side-by-side of from Blade Runner in San Francisco. You know, even though we're all Dodgers here, we can appreciate what's going on for those Giants up in San Francisco. And I like this because the clock shows you it's around 4 o'clock in the afternoon. Again, should be bright daylight, beautiful sunny afternoon. This is one of my favorites. I've lived the last 25 years on this block waiting for this moment. In case you can't see it very well, I'll do a little close up. It says Mars. And it's also apparently the end of the street, so it's Mars End. So that is kind of, I think it kind of sums it up. So Patrick, tell us about the smoke. And I have been looking at the clock and it's unbelievably late. I don't know what happened there, but so we're gonna want to take the pace up a bit.
Okay. Yeah, sure.
So, yeah.
Yeah. So under all those orange skies, we can take a look at the smoke from space. This is from the GOES 17 satellite. And you can see on the coast area there, it's kind of the gray smoke. If we go to the next sequence there, which was on September 10th, I actually pulled the animation from the GOES satellite. You can see some of the smoke, pretty dense, being drawn towards the coast in opposite direction, and some out into the Pacific Ocean. So that's what gave us all those skies for orange skies, that you see in San Francisco. This is also showing some of the particulates that have been swept, the dense particulates over in the west, and some of them been swept down south and to the east. We can take a look at the next image.
Yeah, and notice this is a forecast. So then what actually happened?
Yeah, so a lot of the dense smoke was swept out into the Pacific Ocean over 1 million square miles. And in the next slide, you can see that the dense smoke in the red contour over the west, but over in the orange contour there's a big elongated smoke trail that goes from the west coast 2,000 miles across over to the state of Michigan. And even further than that, people waking up in England saw some kind of orange skies. And in fact, the map that we're enlarging here show that some of the smoke actually was wafted up by the high jet streams over United Kingdom and Europe.
So it wasn't just the GOES satellite that actually is imaging it. There are other data as well from several other NASA satellites, and you can watch as things evolve. And these are kind of a wonderful image that shows also kind of the action of the two Atlantic Ocean storms, Hurricane Sally and the other one, I always forget his name, Paulette. And you can really see how those systems, because of their winds, were blowing it around. Some of the smoke got caught. I mean, it felt so apocalyptic. You've got all this smoke coming from all these fires getting swept up in hurricanes and then swirled around on the East Coast. And I think if anybody still awake here on the East Coast, I heard from friends on the East Coast that they were seeing our smoke. So fortunately, we do have a number of satellites up there monitoring Earth, of which all of these are doing are measuring changes to Earth's atmosphere. And one last little one I want to show you. This is carbon monoxide that is measured coming from the fires, and you can see again, this is now not the smoke, but carbon monoxide, which is a byproduct of fire. So I know I said earlier that Mars one was my favorite of the San Francisco images, but I think maybe that's a close competitor is this one. This is fine. And I hope people watching recognize the cartoon to which this refers. Is it really fine? I don't know that it's exactly fine. As I mentioned earlier, the top six of the top 6 fires in California, 5 of them were this fire season. And if you look in that second column of the date, you just look down that column, you have to go pretty far down. The 13th one is 1932, but the rest of them are all in the last 20 years. So the question is begged, what's happening? Are we getting more fires, worse fires? Is there a change that has meaning, or is it just random and there's no trend? This is an important question that scientists need to ask so we can make predictions, going back to that, about what's going to come and develop theories about why this is happening so we can try to mitigate it. So we have a bunch of data here. Angelica, can you very briefly mention this?
Yes. So, can you hear me? Yeah. So this is something where we see data being compiled that shows that the number of wildfires is increasing as well as the acreage. However, this information is actually coming to us from data that is only counting wildfires that are larger than 500 acres. So there's other graphs that you can find that actually finds the number of fires going down. But this graph is which is from this is actually from a congressional report, is not ruling out the smaller fires. So it seems to be as though maybe we're having fewer number of fires on the whole, but the number of large fires, again, 500 acres or more, is on the increase.
And that is borne out in this slide as well, that the average size of fires is dramatically bigger. So while there's some ambiguity about how you bin the data and so forth in terms of the numbers of fires, there's no ambiguity about the fact that wildfire sizes are definitely on the uptick. And that's why we have some of our biggest ones just, in this past year. So that brings this question: what is the cause, and what can we do to try to turn the tide on this? So if you watch the news, earlier this month, there was a very visible conversation between our governor and our president about what the causes were. And you heard two very important ideas, and both play a part. And so we want to take a look at what the respective roles are of forest management and climate change. So Bill, thank you for joining us. Can you tell us a little bit about forest management?
Yeah, this is one of our beautiful forests of giant sequoia trees, Mariposa Grove, one of our national parks. I'm forgetting now if this is Yosemite or Sequoia, but either way, it's beautiful. So who manages all this? Well, it turns out it's a pretty complex web of people. We have all kinds of agencies and players in this, and it's really summarized well in the next slide, in that in just the state of California, I limited my study of forest management to California, 57% of our lands are actually owned and managed by the federal government, 3% are managed by state and local governments, and the rest is private, either industrial, non-industrial. That also includes Native American lands. So within the federal government, we have three big agencies: the National Forest Service, which they might have the most complex job of all, because the national forests actually allow use. They allow mining and logging and hunting and fishing and all kinds of things. And they have to manage all of that. The National Park Service, of course, are national parks. And then most of the rest of the land comes under the purview of the Bureau of Land Management. So what started all of this fire suppression? Well, a lot of people point that back to this one big fire called, on the next slide here, the Great Fire of 1910. This thing burned 3 million acres, mostly up in Idaho and Montana. It literally completely destroyed 7 towns, killed 87 people, most of whom were firefighters. And this picture is the town of Wallace, which survived, but you can see there's a lot of devastation there. This kind of inspired some policies of fire suppression that lasted a long time. There was the 10 a.m. policy, which said you find a fire on Tuesday, you got to have it managed and controlled by 10 a.m. the next day. There's also the 10-acre policy, which happened very late. That came along in 1971, which said that all fire should be suppressed to 10 acres or less as quickly as possible. So suppression, just see a fire, put it out. Now, why did that change? Well, it turns out that there's a lot of reasons to change this policy, one of which is the fact that forests actually require fire. These are lodgepole pines. It's sort of sad what happened to them. This is big fire, or series of fires, I think, in 1988 in Yellowstone that killed these 200-year-old lodgepole pines. But you see that sea of green at the bottom, that's saplings that cannot germinate without fire. They need fire levels of heat to actually get the seeds out of the pine cones, because they're sealed in by a resin that requires that level of heat to release the seed into the ground and let them grow. And so you can see all that new life coming out of the fact that there was fire. Pretty bad, devastating fire. Okay, so now the Native American peoples of these lands have known this for a long time. These are a couple of guys that are burning bushes that they know will resprout with the rains in the spring. They do it every year. And the people who have lived here the longest have been managing their lands this way for a long time. There's very strong archaeological evidence that this goes back at least centuries, maybe thousands of years before European settlers came. Then finally, we got some sense, and in 1995, the federal, let's see, what is this called? The Federal Wildland Fire Management Policy. It prioritized human life and safe firefighting practices, which is human life also, because that's protecting firefighters. But it also included these, moving on to the next slide, please. Sorry. Moving on even a couple more.
I'm sorry, Bill.
There we go. No, that's all right. That's all right. So yeah, one more, just to see this line here, adopt land management policies that, oh, I've lost it in my notes here. Yeah, adopt land management practices that integrate fire as an essential ecosystem process. We finally got smart and accepted the role of wildfire as an important part of the forest ecosystem. So, and I love this next one. This is an agreement that just happened this year between California and the federal government, and it includes this great line: use science, thank you, to inform and prioritize stewardship decisions. Very, very important stuff. Okay, so how does this all get implemented? Well, I picked Yosemite as one example because I love Yosemite. It's one of my favorite places in the world. We go to just this next slide here. In Yosemite, the policy is basically if a fire starts naturally, and that pretty much means lightning, they will manage it, but they'll allow it to burn. It can't, threaten human life or structures, but otherwise they let it burn as much as possible. Anything that is human started, is like the thing on the right, is immediately suppressed because that shouldn't have happened. We also start fires on purpose. This is El Dorado National Forest, and they call this prescribed fires, meaning fires that are set specifically to be controlled and also to do what fire does, which is burn off all of that, the vegetation, the fuel for future fires that is built up for just at least a century of fire suppression policy. We got to get rid of it because that stuff, that can carry the fire up into the canopy where it really spreads then. So that's what they're doing here. And there's even some of this being done in Yosemite. They don't do it as much, but they do, if they do some mechanical thinning and burning of trees around structures, just in case there is a big fire, they have a little gap, a little defensible space between themselves and the fire. But now I got into forest management that goes way beyond fire because I was asked to, and I'm really glad I was, because in this next slide here, you can see that they do some fascinating stuff.
Well, I think before we go into that.
Oh, I'm sorry.
We need to summarize what we just heard.
They summarize our brilliant new policy. Roll them.
Right. Okay. Yes. This is from the future governor of California, right?
Yeah.
Fire is good. Fire is good. Yes. Fire is our friend. Yes.
Fire is good. Fire is our friend. Well, it is. It's good. All right, so I'm so glad you reminded me of that. Okay, so now
I see what's coming. You cannot. So
I know.
Yeah.
So this is called, they do this tree cruising, they call it. It's just taking measurements of basically collecting data in the forest. Part of this is tree circumferences, which I found out they do both outside and inside the bark. That's important as well. You can see how athletic you have to be on the left here to do that with a giant sequoia tree. That guy's just really stretching himself out to do this. On the right, they're actually measuring burn heights on trees from previous fires. But they do more than forests and trees. They do air quality management. Those are bark beetles on the bottom left. They just sort of symbolize all the sometimes pest and invasive species that they have to deal with. My favorite thing in this picture is on the right, where they're measuring the scent of flowers. And you would think that sounds so poetic, but it really has a purpose because drought can highly affect that. And when drought affects that, it can reduce or actually change the scent of certain flowering plants. And that means possibly pollinators are no longer attracted to them or attracted a lot less. And, flowering plants require pollination to continue. The last thing is that you can help. These are all citizen science projects. I'm just going to talk about that one on the left. The other two are fairly obvious. But the one on the left is really just beautiful. This woman has, I guess they provided this to her, this recording device that records bird songs. And they put these around, and then they take NASA satellite data and they map bird species from that. And I just wish they were doing that in my neighborhood because I'd love to have one of those things in my backyard. And that's it. Anyway, I found out that the forest management stuff in this state is just fascinating. It's fascinating.
So if people want to participate as citizen scientists on some of these forest initiatives, whom should they contact?
I would say the U.S. Forest Service is the best bet, but you can also look at the National Park Service and go to their website as well. I would even check out Bureau of Land Management. I did see that the National Forest Service has specific projects that you can just sign right up for right now. The thing is, I think none of them are in California at the moment, but I'm sure they will be in the future.
Yeah,
take a look. Websites are fantastic. They're so interesting.
So there are two other little features I want to mention. They're related, but kind of cross over between management and climate, and that is for anybody who lives in the Rocky Mountain West, that huge swaths of trees are dying. And they're dying because of an infestation of this little guy, a pine bark beetle. They wreak absolute devastation on the forest across the West. So one of the interesting kind of mitigating factors or exacerbating factors here is that little guy, populations die off in winter. So if winters are not as cold as they once were, and they're not, then we don't kill off as many of them. So it's a sign of imbalance that the pine beetles are winning in some places. And you can see a short map here, the quick map that shows you where insects and disease, the ways in which the ecosystem of the trees themselves being affected then makes them vulnerable to fires. A second thing is just, you mentioned, Bill, that that different trees need fire, and it really depends on the level of fire. I'm going to just kind of skip through this and just say that, there can be fires that are too hot, and these big conflagrations get so hot where now it's not a happy regrowth situation. You really have stunted the ability of trees, and this graph shows this, but I'm not going to take the time to explain it, that the seeds just don't get dispersed as far, and you just don't get that kind of regrowth the way you would if the fires were not as hot, and that temperature comes a lot from massive how massive these fires are. Another piece of this too is, of course, all these conditions, we sort of lump it together, but not necessarily true that it has to be together. But between heat and drought and environmental conditions of the trees themselves and the die-off, the forest management, all of this becomes quite a bit more vulnerable. And they actually have a way of quantifying that as to how vulnerable and how many days of vulnerability there are, risky extreme fire danger days. And you've seen those, if you've ever driven into parks or even into Griffith Park, you'll see a little smoky, and then there's a red, yellow, So there's actually a quantitative thing behind that. And one of the outcomes of a warming planet is that we have not only longer fire seasons, but more of those extreme risk days. And in fact, there were, I guess the number is increasing to 16. I guess I wrote that down, but I don't know increasing from what, so that wasn't very valuable of me, of this year, in a year of extreme fire days for the start of a fire. So, and then the other piece of it is that the backfires, there are fewer days that are safe to start backfires, because you only do backfires on safe days. But if you have these hot, dry, tinder conditions more days a year, then there are fewer days where you can build the backfire. So there's a relationship between these two aspects of forest management and climate that we need to adjust to. So I'm going to wrap up with just a few comments on climate. I mentioned earlier that something I care very deeply about because it's our future. And in All Space Considered, we really haven't talked about climate this year. We all had so much to think about, and there was a lot to worry about with the pandemic. And we just decided we're not going to go there. We're not going to give, talk about this other existential threat that we face. But for many reasons, one certainly being I'm, not probably going to be not at All Space Considered anymore. I wanted to take the time to say a few things about this. So let me just start by saying, with regard to fires and other natural disasters, for quite some time, we have said, scientists have said, that we can't make an association between climate change and an individual fire. You can't say that fire started, or that typhoon happened, or this flood occurred because of climate change. What you could say was that from a statistical point of view, the likelihood increased, or in other words, as an ensemble, there was a greater likelihood. So if you're having more, there's, more of a likelihood that they are related to climate change. You just couldn't make a specific, this fire is tied to it. But you could say as an ensemble, some fraction of them has a higher probability. And once you get the numbers high enough, by then that means they're linked. That's changed. And I didn't really quite fully understand this until I started researching for this show. There has been such an increase in modeling, and that individual incidents can be evaluated in the context of the environment as we know it now, compared to an environment of a planet B, or where planet B is Earth as it might have been, say, 40 or 50 or 100 years ago, in terms of the environment, in terms of the amount of heat, either in the atmosphere or in the ocean, that the planet is absorbed. So I was very surprised to see the number, wrong button, the number of articles that actually link. These are all in journals. Climate change is increasing the likelihood. Okay, that's a likelihood one. But you can see there are specifics that anthropomorphic climate change is related to this marine heat wave. I guess that's also about heat wave. That you could not have had the 2018 heat wave in Japan without it being human-induced climate change. So this scene is changing. So if you have, as I have for quite some time, said, well, as an ensemble on the whole, this is true, but you can't point to it, that is in fact actually changing. So much so that the American Meteorology Society actually puts out an addendum every year that says, that describes specifically, and you can see this is the 2021, I think there's something like 18 or 20 different chapters in there, specifically discussing extreme events and their relationship to the climate, from the American Meteorological Society. And then very recently, there was quite a bit of discussion from a UCLA scientist, Daniel Swain, who is, this is in the same publisher for Cell, is Biology, One Earth is the same publisher. And this whole field of event attribution is a burgeoning field, and has gained a lot of momentum, and more people are publishing in this world. So that's a big change, and I wanted to call that out, not only because I learned it, so I wanted to share it, but because it's important that as we talk about it, as we hear about it in the news, that we come to understand that we do have a way to understand and describe the relationship between climate and these events. And our models are becoming so good that they're within as I said earlier, scientists are very conservative. They're going to say, well, we found phosphine, not we found life. And they'll always say just the barest minimum. So when you get scientists saying, no, this is related, that is something to take note of. So I always kind of let that go in one ear, out the other. But when you look at the cost of fighting, for example, these fires, not even to mention in terms of human life and rebuilding and so forth, it would be unwise to turn our backs on it. I think I believe this to be true with regard to what we've learned to the pandemic. We see that when there are super spreader events, numbers rise. It's exactly what epidemiologists say. The scientists do have ways of knowing what is happening in the natural world and helping us to stay safe. So it would not come as a surprise to anyone that here on this science show, this is I guess a request to share with other people the importance of listening to the scientists, and to not dismiss. When I hear, well, scientists don't really know, it just makes me insane, because there are generations of studies behind this, and science has built into it the mechanism to say, no, you're wrong. I'm going to go measure Venus's atmosphere and we'll see if there's phosphine. But when everyone else measures it and they all find it, then yeah, that's pretty good. So it isn't just here's my opinion, here's your opinion, both are fine. The whole enterprise of science is to pit our best ideas and observations against others and until the correct answer emerges. And yes, that answer changes. That is a strength of science, not a weakness. So I felt a desire to say that at this time and at this incredibly auspicious time in history where we really are at a tipping point. To that end, I want to then very briefly, I'm not going to actually show much. I think you've seen me say things like this before. So I'm just going to say very briefly that there is no doubt that our planet is warming. And I have shown this visual before, but I'm going to do it one more time because it shows so clearly. Each of these circles is a year. You can see November, December, January, so forth. And each year is a new color. Each decade is ranging. I'm going to play that again. We start a little over 100 years ago. Come back to that. And then watch the little, the average global, now we're talking global temperature over the course of, it's back to the 1850s. So you can see what the temperatures look like. You can absolutely see from the colors that that the number, the value is going up. And those values of 1.5 and 2.5 are compared to the average prior to 1850, I believe. So when people say, I don't believe in it, it's not a matter of belief. These are measurements, and it is happening. I'll just briefly say the climate is changing because the globe is warming. The globe is warming. We just saw that. And the science is not complicated. We're pumping gases into the atmosphere that trap heat. And if you have a greenhouse or you've ever sat in a sunny window, you know that that you can trap heat inside. You can warm your living room by letting the sun shine inside, and the heat stays inside. The light comes in, but the heat does not go out. Simple, simple. We've known it for a long, long time. So it's exactly what we expect, and it's exactly what's happening. And then also I want to mention, just because sometimes people still say things like it's gonna, hey, look at the snowball or something. It's the coldest day of the year. It's gonna get cold. Well, yeah, winter's coming. But when you look at averages over the globe and over the years, there is just absolutely no doubt about it. I want to just also briefly address the fact that so many times I hear people say it's happened before. And I have data to these, and happy to answer it after the show with in discussion if people wish. But it has not happened before. It just hasn't happened before. What it is, yes, there's been CO2, higher levels of CO2 in the past, in the distant past. And yes, there have been high global temperatures. But what hasn't happened before is this crazy, crazy rate of change. It's happening in it's the blink of an eye in geological timescales. The changes that we have seen in Earth's history have been spread out over hundreds of thousands of years, millions of years, hundreds of millions of years. That's the rate at which the globe changes, and the life on that globe, on Earth, adapts to that rate of change. There's no time to adapt. This is happening so quickly. It's an imbalance in the system, like we saw with those pine bark beetles. It can't keep up. They aren't just going to start migrating north, or things are going to even out. There isn't enough time for adaptation to work. And then lastly, it cannot be explained without human forcing. Well, yeah, but nature's doing it. It isn't human people doing it, and that is simply false. We now know, and analyses have been done that show that there's utterly impossible to get the levels of from natural processes by looking into just the. You have to have human forced warming. This paper that I'm showing here is also showing just in general the nature of hot days, hot years and cool years. And I thought it's worth showing this again. I showed it about a year ago. That really shows that when you zoom into those last couple of years, you can see there's a little hotter, little cooler. Things are distributed in the past. But since about 1850, it is not an even distribution between hotter years and cooler years. It's hotter years and hotter years and hotter years. So this is not news. There's a zoom into it. And it, as I said, it is unprecedented. This is not how Earth behaves absent us changing it. So you have seen this before. This is the famous hockey stick diagram. I'm not going to talk about it, but the point is the carbon dioxide is rising, the temperature is rising. What does this mean? It's not good. I spoke about a year and a half ago about the IPCC, the Intergovernmental Panel on Climate Change, trying to discern the difference between a 1.5 degree increase and a 2 degree increase. And I showed this graph, so I'm going to briefly show it to you again. This shows the difference, and you can see across the top there, 0.51, 1.52, and what happens in these different environments when you change the temperature that much. The most obvious one is the coral die-off, fourth one down on the left there. We're already in the zone where coral die-off is happening, and I know you've seen images of that. But if you look at the difference between 1.5 and 2, threatened ecosystems, extreme weather events, and as I mentioned earlier, now it's not just statistically, but you can actually attribute specific events, the Arctic melting and so forth. So there is a difference between 1.5 and 2. And here we are at that level. Those are the two, 1.5 and 2. You've also heard, and it's also been shown, that there is a tipping point, a point after which feedback mechanisms exacerbate the situation and make it run away, like it did on Venus, except Venus, it happened over a long period of time. Ours is happening over a very short period of time, again, because of human forcing on the system. So if you've seen something like this, the yellow circles, Greenland ice sheet melts, Arctic summer sea ice, we've already seen that melting, the die-off of this coral reefs, which, by the way, sequester away carbon. All that is happening now. We see it. And but again, in a positive feedback way, as you melt off the ice, the highly reflective ice, and replace it with dark water, Earth absorbs more sunlight and it heats even more. So that is a positive feedback type situation where the more it melts, the more it warms, so the more it melts, and so the more it warms, and it feeds back on itself. That kicks us into that next range of orange, where we lose forests. Again, positive feedback. The forests, of course, sequester away, take out of the Earth's atmosphere a lot of carbon dioxide. So if you lose the forest, you lose part of the subtraction on the system, and it's a runaway positive feedback situation. The rainforest of the monsoons, as we saw talking about Arizona. But when that becomes chronic and we just don't get the rains, then again, more drought, more fires, more loss of vegetation, positive feedback, until that finally pushes us into this red zone where you lose the rest of Antarctic's ice, and in particular, you lose the permafrost. The article that this was in said that we are coming to that tipping point. At the time, it said 11 years. That was 2 years ago. And this is why you've heard that number, if you've heard it. And because at some point, it doesn't matter if we figure it out in 2070, because the atmosphere is filled with this stuff and with the greenhouse gases, and we can't get it out of the atmosphere fast enough. It's already been shown that cutting back emissions alone is not enough. We have to take more out of the atmosphere. So you've heard all the normal things about, conserving electricity, driving electric cars, and so forth. I want to, needless to say, this is not a good situation. So I want to end with a few things that you can do, and urge you to share these with others. Certainly, we've talked about renewable power, renewable electricity, like these solar and wind panels, and that takes the burden off of fossil fuel burning, carbon CO2 emitting sources. But what you may not know about is that you can do it right now. Every utility in every city I've lived in for the last 20 years, and I'm guessing it's probably pretty much every utility around the country, has a way that you can pay cents more per kilowatt hour, I mean, small amounts, to buy green energy. And because the utilities buy their power, and they buy them from different sources. So for a very small premium, you can sign up and just, then even though you don't have to put up your own solar panels, you just sign up for the green power on your bill. You pay a little bit more, but it's not much. I remember one of our staff, Jeff, did a calculation. He saw his bill was going to go up. He lives in an apartment. Was going to go up $7 a month. He thought, I can pay $7 a month to have it be completely green. So that, of course, also puts pressure on the markets. We don't have time to go into all of that. Would love to, but don't have time. So please consider doing that. You've probably heard we need to plant more trees. We just lost a whole bunch of trees. So planting trees is absolutely essential because photosynthesis, they take the carbon dioxide out of the atmosphere. This map shows us from a paper last year of all of the areas that have the potential for greening up. And there's some amazing stories of success of arid places that you start to plant grasses and then trees, and you start to retain the water, and then there's just more moisture, and next thing you know, you've got you're not a desert anymore. It reverses the desertification. And then the last of these, or second to last, is something very near and dear to my heart. And so I just want to speak to it one last time. And that is care for and stewardship of Earth's soil. Some of you know that I was a spokesperson related to this soil initiative and with the U.S. Department of Agriculture, that it's amazing what soil can do. The idea here is that with the Dust Bowl, since industrial agriculture began, we've lost 1/3 of our topsoil. It's turned from organic soil into dusty dirt and eroded away, blown away. We are at a risk of losing the rest if we continue our farming practices the way they are. And in a documentary I recently watched, they said we have 60 harvests left. In 60 years, the other 2/3 will be gone. It's a remarkable a remarkable number to contemplate. So that's our food supply, and the soil, remediating the soil and turning it back to a living organism will sequester away enormous amounts of carbon. The way that works is the plants take the carbon out of the oxygen, feed it to the roots, and then in the roots, microbial systems and whole ecosystems of microbes engulf the soil and sequester away that carbon. At the Paris Climate Accord, there was a remarkable notion that 30 countries signed on to called 4 in 1,000. And the idea is that for every 1,000 acres, if you changed 4 acres through these practices, through the practices of no tilling, no pesticides, you don't want to kill off the microbes, you don't want to overturn the soil and kill off the microbes. Everything's about feeding the microbes, cover crops year round. So there's always a way to feed the microbes. In other words, keep the microbes alive. 4 acres out of 1,000 is enough to offset our yearly CO2 emissions globally. It's incredible. And then add to it, I mean, there's so much more, but save the food supply. And guess what? Beef is fine because cattle walking through, as long as you keep them moving. In fact, the idea that you till up all the soil, grow all this food so that you can feed cattle in a lot and keep them all stuck together where they have to be on all these drugs and make each other sick anyway. When in fact the cattle could be grazing, you just need them to keep moving around because they're trampling along, not to mention their digested food ending up in piles on the soil, help feed the microbes. So this whole thing about they want to take your hamburger away is just insane. This is a solution that gives you your hamburger and other meats as well if you like meat. You don't have to give that stuff up. So don't believe the baloney. There are solutions, and we can turn this around. You never hear that. I know that I have been incredibly unhappy and depressed and thinking that there's no solution, but there is a solution, and we have the power, and we can do it. Because otherwise we really are condemning, and I mean the generation that's living here today, to a very, if you think this year is bad, to a really, really bad future. So we have to make changes. You know, what they say is you can't do the same thing and expect people to expect a different outcome. We have to make changes. And what better time as we come out of this global pandemic? We had a class about this last week, and one of my students made the point, and I thought it was wonderful, that, you know, Reconstruction, the GI Bill, the things that we have done as a nation coming out of tragedies and places where our country has fallen apart, we had to put it back together again. We can put it back together again in a much better way and secure our future. It is within our reach. It's not even that high tech. So I just urge you to share this with others. I do want to give a little shout out, because it's some of the same people that I worked with at the Department of Agriculture, to this. It's on Netflix right now, and it tells all this about the soil. And I hope you will consider spending an evening with this documentary. It will blow your mind, because it'll give you hope. At the end of our global climate change segments in the past, we have always shown pictures of furry little animals because it was all depressing news. And so we had to have furry animals just to like pick up people's spirits. And I also was told by my class that didn't come through. For the people who don't know All Space Considered, they don't know about this. So like, what were those furry animals about? The furry animals are about feeling better after a big load of bad news. So here are requisite furry animals. Now you can feel better. But you know what? You don't have to feel better about furry animals. You can feel better about the fact that you can make these changes. 4 acres out of 1,000 is not a lot. It just takes education. And all of these different, we didn't even talk about Newsom's, Governor Newsom's plan to transition our transportation economy to non-gas cars. You know, it just takes leadership, initiative, and working together. And so we can feel good, not because we're looking at furry animals and trying to avoid what we're feeling, but because there really is hope. That hope does start, so explaining these furry animals with your voice. We have an election coming up. I urge you to look at different candidates' positions on some of these things and think about the change that you want to see. We have, as I said, coming out of this pandemic, we're still in a very, very weird and scary time, but we will come out of this, and it will be up to us and up to each of us to participate in the reconstruction of our society. So I want to hope that you can share in this effort of making this a safer world for all of us. I know we want it. You may not realize that there are things you can do, tangible things, reachable things. This is solvable. So with that, I do want to bring tonight's program to an end. I have two last things to say. One of them is that, again, goodbye. Follow me on Twitter if you would. And in fact, I have that up here too. And I'll just put that up there very briefly and you can show it, Matthew. But I do want to end with a video that Tony pulled out to our attention. It's just beautiful. So Tony, we're going to show this, what we used to call a walkout video. That will be the end of the program. If anyone wants to hang out and discuss this stuff, I think you know we're here, I'm here, I'm happy to talk, take questions. I know there have been some and I have been ignoring them because of the time. So I do want to share with the video we're about to show that our little perspective is about this tiny. There is a much bigger perspective out there to be had of our place in the universe. That's what we try to share every month. So Tony, do you want to tell us what we're about to see?
Yeah, just tell you briefly, I was working late one night. I heard this music actually on a late night PBS show and looked up and I couldn't believe who it was by. It was very lovely and it really caught my attention, but I just couldn't believe the composer, John Cage. And you probably heard about him in the news a couple of weeks ago because one of his last pieces that he wrote, called As Slow as Possible, had its first note change in 18 years. It's being played by a computerized organ in Germany and will last for like 640 years. He's also well known for the silent piece, 4 minutes, 33 seconds. So if you think of him as wild avant-garde stuff, I think you're going to be very, very surprised by this music in a pleasant way.
And we'll be looking at the Orion constellation as it will change over the next 450,000 years. Still very short in terms of global geological changes, but long by human standards. So enjoy.
Yeah, where's the sound?
We don't have the sound.
So Tony, I think it's interesting that Alnitak, Alnilam, and Mintaka are staying all together, it looks like.
Well,
Tony taught me this.
part of this cluster.
Oh, okay.
So once again, good night, everyone. Thank you so much for joining us. And I wish you all good health, good safety, and a happy new year. Happy Halloween, happy all these holidays, and we'll see you again. So show is over. I guess, yeah, cut the stream to the YouTube. And because then we can. Oh, because the thing, or wait, don't stop the stream. Wait, don't stop the stream then. No, record, if you can still record, but just not feed this to the stream, just to have silence us and leave it on that slide.